You are designing a globally distributed web application that must provide low-latency access to users worldwide. The application will use both static and dynamic content and requires a solution for dynamic failover between regions in case of a regional failure. Additionally, the database backend must replicate data between regions for consistency. A. Use CloudFront for static content, Global Accelerator for dynamic content, and Aurora Global Database for backend replication. B. Use Route 53 with geolocation routing, S3 for static content, and RDS multi-AZ for the database. C. Use CloudFront for static content, ALB for dynamic content, and DynamoDB global tables for backend replication. D. Use Route 53 with latency-based routing, CloudFront for static content, and RDS read replicas for database replication. Correct answer, A. Use CloudFront for static content, Global Accelerator for dynamic content, and Aurora Global Database for backend replication. Explanation: CloudFront caches static content at edge locations, reducing latency for users worldwide. Global Accelerator ensures low latency routing for dynamic content and provides automatic failover between regions. Aurora Global Database replicates data between regions with minimal latency, ensuring consistency in a globally distributed application. Why not other options? Option B, Route 53 geolocation routing can direct traffic to the nearest region but doesn't handle dynamic failover effectively. RDS multi-AZ only provides failover within a single region. Option C, ALB doesn't provide low latency routing for global users. DynamoDB Global Tables is suitable for NoSQL, but this scenario requires relational database consistency. Option D, latency-based routing is useful, but RDS read replicas are read-only and cannot serve as a full failover solution. Your company needs to process large volumes of incoming sensor data in real time. The pipeline must scale automatically and store processed data for analytics. You want to minimize infrastructure management and ensure cost efficiency. A. Use EC2 instances with autoscaling, SQS for message queuing, and RDS MySQL for data storage. B. Use Kinesis data streams for ingestion, AWS Lambda for processing, and DynamoDB for storage. C. Use Elastic Beanstalk for application management, S3 for storage, and EMR for processing. D. Use Kinesis data streams for ingestion, AWS Glue for processing, and Redshift for storage. Correct answer, B. Use Kinesis data streams for ingestion, AWS Lambda for processing, and DynamoDB for storage. Explanation: Kinesis data streams enables real-time ingestion and streaming of large amounts of data. AWS Lambda provides a serverless and cost-efficient way to process incoming data in real time. DynamoDB is ideal for storing processed data because it is scalable, fully managed, and integrates seamlessly with serverless architectures. Why not other options? Option A, EC2 requires infrastructure management and isn't cost-efficient for a serverless approach. RDS MySQL doesn't handle high-frequency writes as effectively as DynamoDB. Option C, Elastic Beanstalk is not serverless and introduces overhead. EMR is suited for batch processing, not real-time data streams. Option D, AWS Glue is a serverless ETL tool, but adds latency compared to Lambda. Redshift is optimal for analytics, but it is less suited for real-time data ingestion. A financial services company runs batch jobs that process sensitive data every night. These jobs can take several hours, but they must be completed before 6 a.m. Data security is critical, and the solution should minimize costs. A. Use EC2 on-demand instances with EBS encryption for compute and storage. B. Use EC2 spot instances with EBS encryption and auto-scaling to manage job execution. C. Use AWS Batch with spot instances for compute and S3 for storage. D. Use Lambda functions for compute and S3 with server-side encryption for storage. Correct answer, C. Use AWS Batch with spot instances for compute and S3 for storage. Explanation: AWS Batch simplifies batch job scheduling and execution, managing spot instances to minimize costs. S3 with encryption ensures secure and cost-effective storage for sensitive data. Spot instances significantly reduce costs, while AWS Batch retries jobs in case of spot interruptions. Why not other options? Option A, on-demand instances are reliable, but far more expensive than spot instances. Option B, while auto-scaling helps, manually managing spot instances adds complexity compared to AWS Batch. Option D, Lambda has execution time limits, 15 minutes, making it unsuitable for long-running batch jobs. You need to expose a REST API to external customers. The API should support millions of requests per day and integrate with an existing backend running on EC2 instances. Security is a top priority, and you need to restrict access to authorized clients only. A. Use API gateway with IAM-based authentication and direct integration with EC2. B. Use API gateway with Lambda authorizers and a private integration to EC2. C. Use Elastic Load Balancer in front of EC2 and WAF for security. D. Use API gateway with Cognito user pools and an integration with EC2 autoscaling. Correct answer. B. Use API gateway with Lambda authorizers and a private integration to EC2. Explanation: API gateway provides a secure and scalable API frontend. Lambda authorizers add custom authentication logic to validate incoming requests. A private integration ensures that traffic between API gateway and EC2 remains within a VPC. Why not other options? Option A. IAM-based authentication is suitable for internal users but not practical for external clients. Option C. ELB provides load balancing but lacks API management capabilities. WAF improves security but doesn't handle authentication. Option D. Cognito is suitable for user authentication, but Lambda authorizers provide more flexibility for client-level validation. You are building a multi-region application that requires secure file transfers between clients and S3 buckets in different regions. File uploads should be authenticated, encrypted, and routed to the nearest AWS region for lower latency. A. Use S3 transfer acceleration with IAM roles for authentication and SSE-S3 for encryption. B. Use CloudFront with S3 as the origin and enable HTTPS for encryption. C. Use an Elastic Load Balancer with EC2 instances to proxy uploads to regional S3 buckets. D. Use Route 53 with geolocation routing to direct clients to the nearest S3 bucket. Correct answer: A. Use S3 transfer acceleration with IAM roles for authentication and SSE-S3 for encryption. Explanation: S3 transfer acceleration improves upload performance by routing data through AWS edge locations to the closest S3 bucket. IAM roles authenticate access securely. SSE-S3 ensures server-side encryption for data at rest. Why not other options? Option B. CloudFront improves content delivery but is not designed for direct uploads to S3. Option C. Using an Elastic Load Balancer adds unnecessary complexity and cost compared to S3 transfer acceleration. Option D. Route 53 geolocation routing helps direct traffic but doesn't handle secure uploads or optimize performance. You are designing a stateful application that requires a relational database backend. The application must run in multiple availability zones, AZs, to ensure high availability and automatic failover in case of an AZ failure. A. Use RDS multi-AZ with a read replica for scaling. B. Use Aurora with multi-AZ deployment and enable global database replication. C. Use DynamoDB with global tables for state management. D. Use EC2 instances with MySQL replication configured manually. Correct answer: B. Use Aurora with multi-AZ deployment and enable global database replication. Explanation: Aurora provides automatic multi-AZ failover and high availability. Aurora's global database replication ensures data consistency across regions. Why not other options? Option A. RDS multi-AZ provides failover but lacks the advanced performance and scaling of Aurora. Option C. DynamoDB is a NoSQL database and unsuitable for relational workloads. Option D. Manually managing MySQL replication on EC2 is operationally intensive and error-prone. You need to build a real-time log analytics solution for your application. Logs should be ingested, processed in near real time, and stored for long-term analysis. The solution should minimize operational overhead and support querying of data. A. Use Kinesis data streams for ingestion, Lambda for processing, and S3 for storage. B. Use CloudWatch logs for ingestion, Athena for querying, and Glacier for storage. C. Use OpenSearch, formerly Elasticsearch, for ingestion and querying, and S3 for archival storage. D. Use Kinesis Firehose for ingestion, Redshift for querying, and S3 for storage. Correct answer, C. Use OpenSearch, formerly Elasticsearch, for ingestion and querying, and S3 for archival storage. Explanation: OpenSearch is optimized for indexing and querying log data in real time. S3 provides cost-effective archival storage. Why not other options? Option A, Lambda is not designed for querying large datasets. Option B, CloudWatch logs and Athena work for batch analytics, not real-time use cases. Option D, Redshift is ideal for analytics, but not designed for real-time log processing. You manage multiple AWS accounts. Developers in account A need to access specific S3 buckets in account B. Access should be restricted to only the necessary buckets and actions. A. Use a bucket policy in account B to allow access from IAM users in account A. B. Use IAM roles in account B and allow developers in account A to assume the roles. C. Enable cross-account access using AWS Organization Service Control Policies, SCPs. D. Create IAM users in account B and share their credentials with developers in account A. Correct answer, B. Use IAM roles in account B and allow developers in account A to assume the roles. Explanation: IAM roles allow secure, temporary cross-account access while adhering to the principle of least privilege. Why not other options? Option A, bucket policies don't provide granular, temporary access like IAM roles. Option C, SCPs control account-level permissions but don't grant specific bucket access. Option D, sharing credentials violates security best practices. A team is training a machine learning model that requires significant compute power. The workload runs for several hours and uses training data stored in S3. The team wants to minimize costs and simplify infrastructure management. A. Use EC2 spot instances with EBS for storage and training scripts. B. Use SageMaker for training and S3 for input-output data. C. Use AWS Batch with spot instances for training and S3 for storage. D. Use Lambda functions for training and DynamoDB for intermediate storage. Correct answer: B. Use SageMaker for training and S3 for input-output data. Explanation: SageMaker simplifies machine learning workflows by managing training infrastructure and integrating with S3 for data storage. SageMaker also optimizes costs with managed spot training instances. Why not other options? Option A, spot instances are cost-effective but require manual management of training scripts and infrastructure. Option C, AWS Batch is not optimized for ML workflows compared to SageMaker. Option D, Lambda is not suitable for long-running ML training jobs due to execution time limits. You need to archive large amounts of data to meet compliance requirements. Data must be stored securely for 7 years, and access frequency is low. Cost minimization is a priority. A. Store data in S3 standard with server-side encryption. B. Store data in S3 intelligent tiering with object locks enabled. C. Store data in S3 Glacier Deep Archive with a vault lock policy. D. Store data in EFS with lifecycle policies to transition files to lower-cost storage. Correct answer: C. Store data in S3 Glacier Deep Archive with a vault lock policy. Explanation: S3 Glacier Deep Archive is the most cost-effective storage class for long-term archival with infrequent access. A vault lock policy ensures data immutability for compliance. Why not other options? Option A, S3 standard is too expensive for archival use. Option B, intelligent tiering is not as cost-effective as Glacier Deep Archive for archival workloads. Option D, EFS is a file system, not optimized for long-term archival. You are designing an e-commerce platform that will experience unpredictable traffic spikes during flash sales. The platform must handle the traffic efficiently, maintain session state across multiple instances, and ensure high availability. The database must also handle millions of read requests during these spikes. Options: A. Use auto-scaling with EC2 instances and elastic load balancing, and store session state in DynamoDB. Use RDS MySQL with read replicas for the database. B. Use auto-scaling with EC2 instances and an ALB, and store session state on the EC2 instances. Use Aurora with global database replication for the database. C. Use Lambda functions and API gateway, store session state in ElastiCache, and use DynamoDB for the database. D. Use ECS with Fargate for the application, store session state in S3, and use DynamoDB for the database. Correct answer: A. Use auto-scaling with EC2 instances and elastic load balancing, and store session state in DynamoDB. Use RDS MySQL with read replicas for the database. Explanation: auto-scaling and ELB ensure that your application can handle traffic spikes efficiently. DynamoDB provides a scalable solution for session state storage. RDS MySQL with read replicas handles millions of read requests effectively. Why not other options? Option B, storing session state on EC2 instances does not support horizontal scaling effectively. Option C, Lambda has execution time limits and may not handle long-running operations or complex e-commerce logic. Option D, storing session state in S3 introduces high latency compared to DynamoDB. You are building a data analytics pipeline to process IoT sensor data in real time. The pipeline must ingest data at high throughput, process it in near real time, and store it for querying. The solution must scale automatically and be cost-effective. Options: A. Use Kinesis data streams for ingestion, Lambda for processing, and S3 for storage. Query the data with Athena. B. Use Kafka on EC2 for ingestion, EMR for processing, and Redshift for storage. C. Use Kinesis Firehose for ingestion, AWS Glue for processing, and S3 for storage. Query the data with Athena. D. Use SQS for ingestion, EC2 instances for processing, and DynamoDB for storage. Correct answer: C. Use Kinesis Firehose for ingestion, AWS Glue for processing, and S3 for storage. Query the data with Athena. Explanation: Kinesis Firehose automatically scales for high-throughput ingestion and supports direct delivery to S3. AWS Glue is a serverless ETL tool, ideal for transforming the data. Athena enables cost-effective querying of data stored in S3 without the need for a traditional database. Why not other options? Option A, Lambda may struggle with real-time processing for high-throughput pipelines. Option B, managing Kafka and EMR on EC2 adds operational overhead. Option D, SQS is not designed for real-time ingestion, and EC2 requires infrastructure management. Your company runs critical applications on premises. You need to design a disaster recovery (DR) solution in AWS. The DR environment must remain cost-effective during normal operations, but scale up quickly when a disaster occurs. Options: A. Use EC2 on-demand instances in AWS regions with a multi-AZ RDS database. B. Use a pilot-light strategy with minimal EC2 instances and a scaled-down RDS database. C. Use an active-active setup with data replication across AWS and on-premises. D. Use S3 for backups and spin up EC2 instances only during a disaster. Correct answer: B. Use a pilot-light strategy with minimal EC2 instances and a scaled-down RDS database. Explanation: Pilot-light keeps a small, scaled-down version of your infrastructure running in AWS. This minimizes costs during normal operations and allows you to scale up quickly during a disaster. Why not other options? Option A, on-demand instances and multi-AZ RDS are costlier as they run continuously. Option C, active-active setups are expensive and may not be necessary for Doctor. Option D, spinning up instances from S3 backups adds significant recovery time. You are designing a multi-tier web application with a web front-end, an application layer, and a database layer. The application must be highly available, scalable, and cost-optimized. Options: A. Use EC2 instances with an ALB for the web front-end, ECS for the application layer, and Aurora serverless for the database layer. B. Use Lambda functions for the web front-end, Fargate for the application layer, and DynamoDB for the database layer. C. Use EC2 instances with an NLB for the web front-end, autoscaling for the application layer, and RDS MySQL for the database layer. D. Use Elastic Beanstalk with an ALB and RDS PostgreSQL for the database layer. Correct answer: A. Use EC2 instances with an ALB for the web front-end, ECS for the application layer, and Aurora serverless for the database layer. Explanation: ALB provides load balancing for the web tier. ECS with Fargate manages containerized application workloads without managing servers. Aurora serverless is a cost-effective and scalable solution for the database layer. Why not other options? Option B. Lambda is not suitable for hosting web front-ends. Option C. NLB is not optimized for HTTP/HTTPS traffic compared to ALB. Option D. Elastic Beanstalk simplifies deployment but is less flexible for large-scale architectures. You need to connect your on-premises data center to AWS to run a hybrid cloud environment. The connection must be highly available, with low latency and consistent performance for applications. Options: A. Use a VPN connection with Direct Connect as a backup. B. Use AWS Direct Connect with VPN as a backup. C. Use VPC peering with a Direct Connect gateway. D. Use a transit gateway with VPN tunnels. Correct answer: B. Use AWS Direct Connect with VPN as a backup. Explanation: Direct Connect provides low latency, high bandwidth, and consistent performance for hybrid cloud setups. VPN serves as a reliable backup in case Direct Connect fails. Why not other options? Option A. VPN as the primary connection doesn't provide low latency or consistent performance. Option C. VPC peering is for connecting VPCs, not on-premises data centers. Option D. Transit Gateway supports complex networking but doesn't match the performance of Direct Connect for hybrid setups. You need to archive video files generated by a media processing application. The files are rarely accessed but must be retained for 10 years for compliance. Retrieval times of a few hours are acceptable. Options: A. Use S3 Standard IA with bucket versioning enabled. B. Use S3 Glacier Deep Archive with a lifecycle policy. C. Use EFS with lifecycle policies to move files to infrequent access storage. D. Use S3 Intelligent Tiering with automatic archival enabled. Correct answer: B. Use S3 Glacier Deep Archive with a lifecycle policy. Explanation: S3 Glacier Deep Archive is the most cost-effective solution for rarely accessed data with long-term retention needs. A lifecycle policy automates the transition of objects to Glacier Deep Archive. Why not other options? Option A. S3 Standard IA is more expensive than Glacier Deep Archive for long-term storage. Option C. EFS is not suitable for archival workloads. Option D. Intelligent tiering adds overhead costs for long-term and frequently accessed data. You are designing a globally distributed web application. The web application must serve content with low latency to users worldwide. The backend application must also maintain low latency while accessing data that is replicated across multiple AWS regions. Options: A. Use CloudFront for content delivery, Route 53 for DNS routing, and DynamoDB global tables for the database. B. Use CloudFront for content delivery, Global Accelerator for routing traffic to the nearest region, and Aurora Global Database for the database. C. Use S3 Transfer Acceleration for content delivery, Global Accelerator for DNS routing, and RDS with read replicas for the database. D. Use CloudFront for content delivery, Route 53 for DNS routing, and RDS multi-AZ for the database. Correct answer, A. Use CloudFront for content delivery, Route 53 for DNS routing, and DynamoDB global tables for the database. Explanation: CloudFront ensures fast content delivery globally using edge locations. Route 53 provides low-latency routing for DNS queries. DynamoDB global tables replicate data across multiple regions for low-latency reads and high availability. Why not other options? Option B. Global Accelerator is better for dynamic traffic rather than static content delivery. Option C. S3 transfer acceleration does not replace CloudFront for efficient web application delivery. Option D. RDS multi-AZ does not replicate data across regions. You need to process and analyze large volumes of data collected daily from sensors. The data needs to be ingested into a data lake for storage and then queried by analysts. The solution must be cost-effective and serverless. Options: A. Use Kinesis data streams for ingestion, S3 for storage, and Redshift Spectrum for querying. B. Use Kinesis Firehose for ingestion, S3 for storage, and Athena for querying. C. Use EMR for ingestion and processing, S3 for storage, and Glue Data Catalog for querying. D. Use Data Pipeline for ingestion, S3 for storage, and Redshift for querying. Correct answer: B. Use Kinesis Firehose for ingestion, S3 for storage, and Athena for querying. Explanation: Kinesis Firehose is serverless, cost-effective, and delivers data directly to S3. S3 serves as a data lake for large-scale, low-cost storage. Athena allows querying data directly from S3 without setting up infrastructure. Why not other options? Option A. Redshift Spectrum adds unnecessary complexity and cost compared to Athena for direct S3 querying. Option C. EMR introduces infrastructure management overhead. Option D. Data pipeline is less scalable for high-throughput ingestion. You need to allow an external partner to access a specific S3 bucket securely for uploading files. Access must be temporary, and the partner should not gain access to any other resources. Options: A. Create an IAM user for the partner and attach a policy granting access to the bucket. B. Generate a pre-signed URL for the bucket and provide it to the partner. C. Use AWS Transfer Family to create a secure transfer endpoint for the bucket. D. Create a VPC endpoint for the bucket and allow access from the partner's IP address. Correct answer: B. Generate a pre-signed URL for the bucket and provide it to the partner. Explanation: Pre-signed URLs provide temporary, fine-grained access to S3 buckets without creating IAM users or managing credentials. Why not other options? Option A. Creating an IAM user adds unnecessary security risks and management overhead. Option C. AWS Transfer Family is for managed file transfers over SFTP/FTPS/FTP, which might not fit this use case. Option D. VPC endpoints are for private network access, not external partner access. You are building a fraud detection system for financial transactions. The system must process incoming transactions in real time, apply machine learning models, and notify downstream systems about suspicious activity. Options: A. Use Kinesis data streams for ingestion, Lambda for processing, and SNS for notifications. B. Use SQS for ingestion, EC2 for processing, and SES for notifications. C. Use Kinesis data streams for ingestion, SageMaker for processing, and EventBridge for notifications. D. Use Kafka on EC2 for ingestion, EMR for processing, and SNS for notifications. Correct answer: C. Use Kinesis data streams for ingestion, SageMaker for processing, and EventBridge for notifications. Explanation: Kinesis data stream supports real-time ingestion of financial transactions. SageMaker is a managed service ideal for deploying ML models for fraud detection. EventBridge handles event-driven notifications. Why not other options? Option A. Lambda is unsuitable for advanced ML model processing. Option B. SQS is not designed for real-time ingestion. Option D. Kafka and EMR introduce unnecessary complexity and operational overhead. Your critical application is deployed in Region A. You need to implement disaster recovery in Region B to ensure minimal downtime and data loss in case of a failure. A. Use multi-AZ deployments in Region A and enable S3 cross-region replication for backups. B. Use Route 53 latency-based routing, replicate the database to Region B, and launch instances in Region B during failover. C. Use Global Accelerator for traffic routing, DynamoDB global tables for data replication, and auto-scaling for instances in both regions. D. Use CloudFront with a backup origin in Region B and enable RDS multi-AZ for database replication. Correct answer. B. Use Route 53 latency-based routing, replicate the database to Region B, and launch instances in Region B during failover. Explanation: Route 53 latency-based routing ensures users are routed to the fastest available region. Database replication ensures minimal data loss, and launching instances only during failover keeps costs low. Why not other options? Option A, multi-AZ is confined to a single region and does not provide disaster recovery. Option C, Global Accelerator is not a disaster recovery solution, it optimizes global traffic routing. Option D, CloudFront does not handle application-level disaster recovery. Your company runs a batch processing job daily, which lasts for 3 hours. The job requires a large number of compute resources, but can tolerate interruptions. A. Use on-demand EC2 instances with auto-scaling. B. Use reserved EC2 instances with auto-scaling. C. Use spot instances with auto-scaling. D. Use Lambda functions to process the job. Correct answer. C. Use spot instances with auto-scaling. Explanation: Spot instances offer significant cost savings for workloads that can tolerate interruptions. Auto-scaling ensures the required number of instances are available during the job's execution. Why not other options? Option A, on-demand instances are more expensive. Option B, reserved instances are cost-effective for predictable, long-term workloads, not daily batch jobs. Option D, Lambda has limits on execution time and may not handle large batch processing jobs. Your company wants to migrate a legacy monolithic application to AWS. The application consists of a web server and a database server. It requires high availability, the ability to handle spikes in traffic, and minimal operational overhead. A. Use EC2 auto-scaling with an RDS multi-AZ database deployment. B. Use Elastic Beanstalk for the web application and RDS multi-AZ for the database. C. Use ECS with Fargate for the application and DynamoDB for the database. D. Use EC2 instances with an EFS file system and an RDS read replica for scaling the database. Correct answer. B. Use Elastic Beanstalk for the web application and RDS multi-AZ for the database. Explanation: Elastic Beanstalk abstracts infrastructure management, provides high availability with minimal overhead, and automatically scales the application. RDS multi-AZ ensures high availability for the database with automatic failover. Why not other options? Option A, EC2 auto-scaling requires more operational management compared to Elastic Beanstalk. Option C, ECS with Fargate is suitable for microservices, but adds unnecessary complexity for a monolithic application. Option D, EFS is unnecessary for the application, and RDS read replicas do not provide failover support. Your company processes IoT sensor data in real time and performs analytics. The data must be ingested, processed, and stored for querying later. The solution must minimize latency. A. Use Kinesis data streams for ingestion, Lambda for processing, and S3 for storage. B. Use Kinesis data firehose for ingestion, EMR, for processing, and DynamoDB for storage. C. Use Kafka on EC2 for ingestion, Lambda for processing, and Redshift for storage. D. Use Kinesis data streams for ingestion, Kinesis Analytics for processing, and S3 for storage. Correct answer. D. Use Kinesis data streams for ingestion, Kinesis Analytics for processing, and S3 for storage. Explanation: Kinesis data streams provides real-time ingestion of IoT sensor data. Kinesis Analytics processes streaming data in real time using SQL queries. S3 offers cost-effective and scalable storage. Why not other options? Option A, Lambda is not optimized for real-time analytics of high-throughput streaming data. Option B, EMR adds unnecessary overhead for real-time analytics. Option C, Kafka on EC2 requires significant operational effort, and Redshift is not ideal for streaming ingestion. You want to host a static website with SSL, HTTPS, support. The website must be globally available with low latency. A. Host the website on S3 with CloudFront for distribution and ACM for SSL certificates. B. Host the website on EC2 with an application load balancer and ACM for SSL certificates. C. Host the website on Lightsail with a custom domain and SSL from a third-party provider. D. Host the website on S3 with Route 53 for distribution and a self-signed SSL certificate. Correct answer. A. Host the website on S3 with CloudFront for distribution and ACM for SSL certificates. Explanation: S3 provides simple and cost-effective hosting for static websites. CloudFront ensures low latency and global availability. ACM provides free and managed SSL certificates. Why not other options? Option B, EC2 and ALB add unnecessary complexity and costs for a static website. Option C, Lightsail is better suited for dynamic applications rather than static websites. Option D, self-signed SSL certificates are not trusted by browsers. Your organization uses multiple AWS accounts for different teams. You need to allow the development team in Account A to access an S3 bucket in Account B securely, following AWS best practices. A. Create an IAM user in Account B, attach an S3 access policy, and share the credentials with the development team. B. Use AWS organizations to allow cross-account access to the S3 bucket. C. Configure a bucket policy in Account B to allow access from the IAM roles in Account A. D. Use Resource Access Manager, RAM, to share the S3 bucket with Account A. Correct answer. C. Configure a bucket policy in Account B to allow access from the IAM roles in Account A. Explanation: bucket policies allow fine-grained access control across accounts by specifying conditions for access. Using IAM roles in Account A ensures temporary, secure access without sharing credentials. Why not other options? Option A, sharing credentials is insecure and violates AWS best practices. Option B, AWS organizations is for account management, not direct resource access. Option D, RAM is not used for S3 bucket sharing. Your company runs an RDS MySQL database that is used only during business hours. You need to reduce costs while maintaining availability during working hours. A. Switch to an Aurora serverless cluster. B. Use RDS with multi-AZ and reserved instances. C. Use DynamoDB with on-demand capacity mode. D. Schedule the database to start and stop during business hours using AWS Lambda. Correct answer. D. Schedule the database to start and stop during business hours using AWS Lambda. Explanation: scheduling the start/stop of RDS during business hours significantly reduces costs while maintaining availability when needed. Why not other options? Option A, Aurora serverless is cost-effective but not suitable for MySQL compatibility in this case. Option B, reserved instances reduce costs but are less flexible for infrequent usage. Option C, DynamoDB is not a relational database and would require significant re-architecture. Your organization generates 10 terabytes of log data daily. The logs must be retained for compliance for 7 years and queried occasionally. The solution should minimize costs while maintaining query capability. A. Use S3 Standard for storage and Redshift for querying. B. Use S3 Glacier Deep Archive for storage and Athena for querying. C. Use S3 Intelligent Tiering for storage and EMR for querying. D. Use DynamoDB for storage and Glue for querying. Correct answer. B. Use S3 Glacier Deep Archive for storage and Athena for querying. Explanation: S3 Glacier Deep Archive is the most cost-effective option for long-term data storage. Athena can query archived data using the S3 Restore feature to temporarily retrieve objects for querying. Why not other options? Option A, S3 standard is expensive for long-term storage, and Redshift is not optimized for occasional queries. Option C, intelligent tiering adds unnecessary costs, and EMR is overkill for simple queries. Option D, DynamoDB is not suitable for storing large volumes of log data or unstructured data. Your team is building an API that integrates with backend Lambda functions. The API must handle a high volume of requests, ensure low latency, and enforce authorization using an existing identity provider, IDP. A. Use API gateway with Lambda authorizers. B. Use API gateway with Amazon Cognito for authentication. C. Use a load balancer with EC2 and integrate IAM for authentication. D. Use API gateway with IAM roles for authorization. Correct answer. B. Use API gateway with Amazon Cognito for authentication. Explanation: API gateway is the ideal choice for serverless APIs with high scalability. Amazon Cognito integrates easily with external IDPs and provides secure user authentication. Why not other options? Option A, Lambda authorizers add complexity and are less efficient compared to Cognito for user authentication. Option C, load balancers and EC2 are less cost-effective and introduce more operational overhead. Option D, IAM roles are not suitable for fine-grained, user-level access control. You manage a critical application hosted in an on-premises data center. The business requires a disaster recovery solution on AWS that ensures minimal downtime and minimal data loss. Options: A. Set up a pilot-light architecture with minimal infrastructure running in AWS. B. Use AWS Backup to replicate on-premises data to S3 Glacier. C. Use a warm standby architecture with scaled-down instances in AWS. D. Implement a multi-AZ setup on AWS and replicate the entire data center. Correct answer. C. Use a warm standby architecture with scaled-down instances in AWS. Explanation: a warm standby ensures that the application is always available in AWS with minimal infrastructure, providing faster recovery during a disaster. Why not other options? Option A, Pilot Lite provides slower recovery compared to warm standby. Option B, AWS Backup does not handle compute resources or provide rapid failover. Option D, a multi-AZ setup is not applicable for an on-premises data center. Your company has a stateless web application running on EC2 instances behind an application load balancer, ALB. The application must scale automatically based on traffic while optimizing costs. Options: A. Use EC2 auto-scaling with on-demand instances. B. Use EC2 auto-scaling with a combination of on-demand and spot instances. C. Use Lambda to replace the EC2 instances and remove the ALB. D. Use EC2 reserved instances with manual scaling. Correct answer: B. Use EC2 auto-scaling with a combination of on-demand and spot instances. Explanation: combining on-demand for baseline capacity and spot instances for additional capacity ensures cost optimization while maintaining availability. Why not other options? Option A, using only on-demand instances is costlier. Option C, Lambda is not a direct replacement for EC2 in a stateless application requiring constant uptime. Option D, reserved instances lack flexibility for dynamic scaling. A financial organization needs to detect fraudulent transactions in real time. The system must ingest large volumes of transactional data and perform analytics with low latency. Options: A. Use Kinesis data streams with Lambda for analytics. B. Use SQS with a fleet of EC2 instances for data ingestion and processing. C. Use DynamoDB streams with Lambda for analytics. D. Use EMR with S3 for batch analytics. Correct answer: A. Use Kinesis data streams with Lambda for analytics. Explanation: Kinesis data streams is designed for real-time ingestion and analytics of large volumes of data. Lambda processes the stream data with low latency. Why not other options? Option B, SQS is not optimized for real-time data streaming. Option C, DynamoDB Streams is not suitable for large-scale analytics. Option D, EMR with S3 is better for batch analytics, not real-time analytics. Your organization operates in a hybrid cloud setup and requires secure and low-latency connectivity between on-premises data centers and AWS. Options: A. Use AWS Direct Connect for a dedicated connection. B. Use site-to-site VPN over the Internet. C. Use CloudFront for low-latency connectivity. D. Use S3 Transfer Acceleration for secure data transfer. Correct answer: A. Use AWS Direct Connect for a dedicated connection. Explanation: Direct Connect provides a dedicated, private network connection with lower latency and higher security compared to internet-based solutions. Why not other options? Option B, site-to-site VPN relies on the internet, resulting in higher latency and less reliability. Option C, CloudFront is for content delivery, not network connectivity. Option D, S3 Transfer Acceleration is specific to S3 uploads/downloads and does not support general connectivity. You run a serverless application using AWS Lambda. The functions frequently hit the 15-minute execution time limit due to complex processing. You need to optimize the architecture to reduce costs and ensure timely execution. 2. Options: A. Use step functions to break down the processing into smaller tasks. B. Increase the memory allocated to Lambda functions. C. Switch to Fargate to handle long-running processes. D. Use EC2 instances with auto-scaling to replace Lambda. Correct answer: A. Use step functions to break down the processing into smaller tasks. Explanation: Step functions orchestrate Lambda functions into smaller, manageable tasks, ensuring efficient execution and cost optimization. Why not other options? Option B, increasing memory may not solve the problem of exceeding the time limit. Option C, Fargate is more costly and adds operational complexity. Option D, EC2 instances are less cost-effective for a serverless application. Your e-commerce application is hosted in the East 1 region and needs to be made resilient to regional failures. The solution should minimize data loss and recovery time while being cost-effective. Options: A. Use Route 53 for DNS failover and replicate data across S3 buckets in multiple regions. B. Use CloudFront with an origin failover setup between East 1 and West 2. C. Use RDS with a cross-region read replica and set up auto-scaling groups in both regions. D. Use Global Accelerator for failover and replicate EC2 instances across multiple regions manually. Correct answer: C. Use RDS with a cross-region read replica and set up auto-scaling groups in both regions. Explanation: Cross-region RDS read replicas ensure the database is synchronized and available in another region. Auto-scaling groups allow the application to scale dynamically during a failover. Why not other options? Option A, S3 is not suitable for transactional data like databases. Option B, CloudFront origin failover is limited to caching, not suitable for active databases or application failover. Option D, Global Accelerator doesn't handle application state synchronization across regions. You need to build a data pipeline that ingests data from IoT devices, processes it in real time, and stores it in a NoSQL database. The solution should be highly scalable and cost-effective. Options: A. Use Kinesis data streams for ingestion, Lambda for processing, and DynamoDB for storage. B. Use SQS for ingestion, EMR for processing, and RDS for storage. C. Use IoT Core for ingestion, Glue for processing, and S3 for storage. D. Use API Gateway for ingestion, EC2 for processing, and Aurora for storage. Correct answer: A. Use Kinesis data streams for ingestion, Lambda for processing, and DynamoDB for storage. Explanation: Kinesis data streams is ideal for real-time data ingestion from IoT devices. Lambda processes the data on the fly, and DynamoDB provides a scalable, NoSQL storage solution. Why not other options? Option B, SQS is not optimized for real-time streaming, and EMR is overkill for simple data processing. Option C, Glue is better for batch processing, not real-time. Option D, EC2 is less cost-effective than Lambda for a serverless architecture. Your company stores 50 terabytes of historical data, which is rarely accessed but must be retained for compliance purposes. The solution should minimize costs. Options: A. Use S3 standard for storage and enable lifecycle policies to move data to Glacier. B. Use S3 Glacier Deep Archive and enable lifecycle policies. C. Use EBS snapshots and store them in S3. D. Use S3 intelligent tiering with automatic cost optimization. Correct answer: B. Use S3 Glacier Deep Archive and enable lifecycle policies. Explanation: S3 Glacier Deep Archive is the most cost-effective option for long-term, rarely accessed data. Lifecycle policies automate the transition of data from S3 standard to Glacier. Why not other options? Option A, S3 standard is more expensive for long-term storage. Option C, EBS snapshots are not cost-efficient for long-term archival. Option D, intelligent tiering adds unnecessary costs for infrequently accessed data. Your organization uses multiple AWS accounts for different teams. You need to centralize access management while adhering to the principle of least privilege. Options: A. Use AWS organizations with SCPs to enforce account-level permissions. B. Use IAM roles in each account and share them across accounts. C. Use AWS IAM Identity Center, AWS SSO, for centralized access. D. Use IAM policies with a shared IAM user across accounts. Correct answer: C. Use AWS IAM Identity Center, AWS SSO, for centralized access. Explanation: AWS IAM Identity Center allows centralized, secure access management across multiple AWS accounts and integrates with identity providers. Why not other options? Option A, SCPs enforce permissions but do not manage user identities. Option B, managing IAM roles across accounts is complex and prone to errors. Option D, sharing an IAM user across accounts violates best practices. You are hosting a relational database for a critical application. The database must be highly available, and downtime must be minimized during maintenance. Options: A. Use RDS multi-AZ deployment. B. Use RDS with read replicas. C. Use DynamoDB with on-demand capacity. D. Use an EC2 instance with a MySQL database and EBS snapshots. Correct answer: A. Use RDS multi-AZ deployment. Explanation: RDS multi-AZ provides automated failover to a secondary instance during maintenance or outages, ensuring high availability. Why not other options? Option B, read replicas are for scaling reads, not for high availability. Option C, DynamoDB is NoSQL, not suitable for relational database requirements. Option D, managing a database on EC2 lacks automated failover and adds operational overhead. Your application is a social media platform experiencing unpredictable traffic spikes. You want to handle the bursts while keeping costs low. Options: A. Use auto-scaling with on-demand instances. B. Use auto-scaling with a mix of on-demand and spot instances. C. Use Lambda with API Gateway to replace EC2. D. Use EC2 reserved instances with manual scaling. Correct answer: B. Use auto-scaling with a mix of on-demand and spot instances. Explanation: a mix of on-demand, for steady traffic, and spot instances, for burst traffic, ensures cost efficiency while maintaining performance. Why not other options? Option A, on-demand instances alone are more expensive. Option C, Lambda may not handle complex or stateful applications efficiently. Option D, reserved instances do not support dynamic scaling. Your application serves a global audience and must ensure low-latency access for users worldwide. Options: A. Use CloudFront with S3 as the origin. B. Use Global Accelerator with endpoints in multiple regions. C. Use Route 53 with geolocation routing. D. Use an auto-scaling group with EC2 instances across regions. Correct answer: B. Use Global Accelerator, with endpoints in multiple regions. Explanation: Global Accelerator optimizes traffic routing across regions using the AWS Global Network, ensuring low latency and high availability. Why not other options? Option A. CloudFront is effective for static content but not for dynamic applications. Option C. Route 53 geolocation routing helps route traffic but does not reduce latency. Option D. EC2 across regions lacks intelligent routing and introduces more management complexity. You need to build a data lake on AWS to store structured and unstructured data from multiple sources. The solution must allow querying the data using SQL without the need to move it. Options: A. Use S3 for storage and Athena for querying. B. Use S3 for storage and Redshift Spectrum for querying. C. Use EFS for storage and EMR for querying. D. Use DynamoDB for storage and Glue Data Catalog for querying. Correct answer: A. Use S3 for storage and Athena for querying. Explanation: S3 is a cost-effective, durable, and scalable storage solution for a data lake. Athena enables querying data directly from S3 using SQL without moving the data. Why not other options? Option B. Redshift Spectrum incurs higher costs and is more suitable for complex queries on structured data. Option C. EFS is not cost-effective or scalable for data lake use cases. Option D. DynamoDB is not suitable for unstructured data storage. You are tasked with designing a highly available and cost-effective architecture for a web application deployed in the East 1 region. The application uses a relational database and must withstand the failure of an availability zone, AZ. Options: A. Deploy EC2 instances in a single AZ and use RDS in multi-AZ mode. B. Deploy EC2 instances in multiple AZs, use RDS in multi-AZ mode, and place an elastic load balancer, ELB, in front of the instances. C. Use Elastic Beanstalk with an auto-scaling group spanning multiple AZs and an RDS instance in a single AZ. D. Use EC2 instances in a single AZ with an ELB and RDS in read replica mode. Correct answer: B. Deploy EC2 instances in multiple AZs, use RDS in multi-AZ mode, and place an Elastic Load Balancer, ELB, in front of the instances. Explanation: Deploying EC2 instances in multiple AZs with an ELB ensures high availability for the application layer. RDS in multi-AZ mode provides automated failover for the database in case of an AZ failure. Why not other options? Option A. Deploying EC2 in a single AZ doesn't protect against AZ failures. Option C. Elastic Beanstalk simplifies deployment, but RDS in a single AZ introduces a single point of failure. Option D. RDS read replica is for read scaling, not high availability. Your company wants to host a static website for its product documentation. The website should scale globally, and the architecture should be cost-effective. Options: A. Use EC2 instances with an auto-scaling group and an application load balancer, ALB. B. Use S3 with CloudFront as a content delivery network, CDN. C. Use Elastic Beanstalk with a single EC2 instance. D. Use EFS with EC2 instances across multiple AZs. Correct answer: B. Use S3 with CloudFront as a content delivery network, CDN. Explanation: S3 provides highly scalable and cost-effective storage for static content. CloudFront improves performance by caching content globally. Why not other options? Option A. EC2 is overkill for static content and incurs unnecessary costs. Option C. Elastic Beanstalk is not optimized for hosting static websites. Option D. EFS is for shared file systems, not static website hosting. You are building an API that third-party applications will access. The API must be secured, scalable, and able to handle unpredictable traffic spikes. Options: A. Use API Gateway with Lambda authorizers for authentication and EC2 for backend processing. B. Use an ALB for API routing, IAM for authentication, and EC2 for backend processing. C. Use API Gateway with Lambda for backend processing and Cognito for user authentication. D. Use API Gateway with RDS as the backend and IAM roles for authentication. Correct answer, C. Use API Gateway with Lambda for backend processing and Cognito for user authentication. Explanation: API Gateway provides a scalable entry point for the API. Lambda eliminates the need for managing servers. Cognito handles user authentication securely. Why not other options? Option A, using EC2 for backend processing adds unnecessary management overhead. Option B, ALB doesn't provide API-specific features like throttling or caching. Option D, RDS is not suitable as a direct backend for APIs. Your organization collects large volumes of log data daily. You need to process this data in batches, perform ETL, extract, transform, load, operations, and store the results in a data warehouse. Options: A. Use EMR for processing, Glue for ETL, and Redshift for storage. B. Use Kinesis data streams for ingestion, Lambda for processing, and DynamoDB for storage. C. Use Glue for processing, Athena for querying, and S3 for storage. D. Use EC2 with custom scripts for processing and RDS for storage. Correct answer: A. Use EMR for processing, Glue for ETL, and Redshift for storage. Explanation: EMR is ideal for large-scale data processing using distributed frameworks like Apache Spark. Glue simplifies ETL tasks, and Redshift is optimized for data warehousing. Why not other options? Option B, Kinesis and Lambda are for real-time processing, not batch analytics. Option C, Glue and Athena are suitable for ad hoc querying but not for large-scale processing. Option D, using EC2 with custom scripts is not scalable and introduces operational complexity. Your application must replicate critical data between regions for disaster recovery. The solution should provide low-latency replication and ensure data consistency. Options: A. Use S3 cross-region replication with versioning enabled. B. Use RDS with a cross-region read replica. C. Use DynamoDB global tables. D. Use data sync for scheduled replication. Correct answer: C. Use DynamoDB global tables. Explanation: DynamoDB global tables provide multi-region, active-active replication with low latency and strong consistency. Why not other options? Option A, S3 cross-region replication is suitable for objects but not for transactional data. Option B, RDS read replicas are read-only and not active-active. Option D, data sync is for batch replication, not real-time. Your application stores sensitive data that must comply with strict encryption requirements. The solution must minimize overhead and integrate seamlessly with AWS services. Options: A. Use KMS to encrypt data stored in S3 and RDS. B. Use EC2 with custom encryption libraries. C. Use CloudHSM for encryption and manage keys manually. D. Use an external key management service and integrate via API. Correct answer: A. Use KMS to encrypt data stored in S3 and RDS. Explanation: KMS integrates seamlessly with S3 and RDS for encryption, making it cost-effective and easy to manage. Why not other options? Option B, custom encryption libraries increase complexity and operational burden. Option C, CloudHSM is more suitable for niche use cases requiring dedicated hardware. Option D, external services add latency and increase costs. Your organization runs some workloads on-premises and wants to securely connect them to AWS resources in a VPC. Options: A. Use Direct Connect with a private virtual interface. B. Use VPN gateway with IPsec tunnels. C. Use Transit Gateway to connect the on-premises network. D. Use VPC peering for on-premises connectivity. Correct answer: A. Use Direct Connect with a private virtual interface. Explanation: Direct Connect provides a dedicated, high-bandwidth connection to AWS with low latency. Why not other options? Option B, VPN gateway is suitable for low bandwidth needs, but less reliable for large workloads. Option C. Transit Gateway connects multiple VPCs but is not designed for hybrid connectivity alone. Option D. VPC peering is for connecting VPCs, not on-premises networks. You are building a serverless web application that requires user authentication. The solution must be scalable, cost-effective, and minimize operational overhead. Options: A. Use API Gateway, Lambda, and DynamoDB for the backend, and manage user authentication with IAM. B. Use API Gateway, Lambda, and DynamoDB for the backend, and manage user authentication with Cognito. C. Use EC2 for the backend, ALB for routing, and RDS for authentication storage. D. Use Elastic Beanstalk with Lambda authorizers, and manage authentication with S3. Correct answer: B. Use API Gateway, Lambda, and DynamoDB for the backend, and manage user authentication with Cognito. Explanation: Cognito is purpose-built for user authentication and integrates seamlessly with API Gateway. API Gateway and Lambda provide serverless compute, while DynamoDB handles scalable data storage. Why not other options? Option A. IAM is not designed for user authentication for a web application. Option C. EC2 and RDS introduce unnecessary operational overhead and higher costs. Option D. S3 is not an authentication service, and Beanstalk isn't required for this architecture. Your company needs to process streaming data from IoT devices in real time and store the results in a relational database for reporting. Options: A. Use Kinesis data streams for ingestion, Lambda for processing, and DynamoDB for storage. B. Use Kinesis data streams for ingestion, Kinesis data analytics for processing, and RDS for storage. C. Use SQS for ingestion, Lambda for processing, and Aurora for storage. D. Use SNS for ingestion, Kinesis data analytics for processing, and DynamoDB for storage. Correct answer: B. Use Kinesis data streams for ingestion, Kinesis data analytics for processing, and RDS for storage. Explanation: Kinesis data streams handles real-time ingestion. Kinesis data analytics processes streaming data in real time. RDS provides a relational database for reporting. Why not other options? Option A. DynamoDB is not ideal for analytical reporting. Option C. SQS is not a streaming data service. Option D. SNS is for notifications, not streaming data ingestion. You are tasked with implementing a disaster recovery plan for an application running in the East 1 region. The application uses stateful data stored in RDS and must be recovered in another region with minimal downtime. Options: A. Use RDS read replica in another region and promote it during a disaster. B. Use S3 cross-region replication and manually rebuild the database in the disaster region. C. Use RDS multi-AZ with a failover to another region. D. Use AWS backup to take snapshots and restore in the disaster region. Correct answer: A. Use RDS read replica in another region and promote it during a disaster. Explanation: RDS read replica in another region provides a copy of the database that can be promoted as a primary instance. Why not other options? Option B. Manually rebuilding the database leads to significant downtime. Option C. Multi-AZ failover only works within the same region. Option D. Restoring from AWS backup snapshots is slower than promoting a read replica. Your company plans to migrate a monolithic on-premises application to AWS. The application requires low-latency access to a relational database and must remain highly available during the migration. Options: A. Use EC2 instances with an application load balancer, ALB, and RDS in multi-AZ mode. B. Use Elastic Beanstalk with an ALB and RDS in a single AZ. C. Use Lambda functions with DynamoDB and a global accelerator. D. Use EC2 instances with a network load balancer, NLB, and Aurora global database. Correct answer: A. Use EC2 instances with an application load balancer, ALB, and RDS in multi-AZ mode. Explanation: EC2 provides flexibility to lift and shift the monolithic application. ALB and RDS multi-AZ ensure high availability. Why not other options? Option B. RDS in a single AZ introduces a single point of failure. Option C. Lambda and DynamoDB are unsuitable for monolithic applications. Option D. NLB is for TCP/UDP traffic and not suitable for HTTP-based applications. Your organization has multiple AWS accounts, and you need to allow engineers from one account to access resources in another account securely. Options: A. Use IAM roles with cross-account trust policies. B. Use AWS SSO and share credentials manually. C. Use IAM users and duplicate the user accounts in each AWS account. D. Use Resource Access Manager, RAM, to replicate permissions across accounts. Correct answer: A. Use IAM roles with cross-account trust policies. Explanation: IAM roles with cross-account trust policies allow secure access without duplicating users. Why not other options? Option B. AWS SSO doesn't provide direct resource access across accounts. Option C. Managing duplicated IAM users is error-prone and not scalable. Option D. RAM shares resources, not permissions. You have a data analytics pipeline that transfers terabytes of data from on-premises to S3 daily. The solution should minimize transfer costs. Options: A. Use AWS Direct Connect with a public virtual interface. B. Use AWS Snowball Edge for bulk data transfer. C. Use AWS Data Sync over the Internet. D. Use a VPN gateway with S3 transfer acceleration. Correct answer: A. Use AWS Direct Connect with a public virtual interface. Explanation: Direct Connect reduces transfer costs for high-volume, consistent data transfer. Why not other options? Option B. Snowball Edge is for one-time bulk transfers, not daily operations. Option C. Data sync over the Internet incurs higher data transfer costs. Option D. S3 transfer acceleration is for speeding up, not reducing costs. You are developing a backend API for a mobile application. The API should handle authentication securely, scale with unpredictable workloads, and be cost-effective. Sensitive data should be encrypted in transit and at rest. Options: A. Use API Gateway, Lambda, Cognito for authentication, and DynamoDB for storage. B. Use EC2 instances behind an ALB, manage authentication with IAM, and store data in RDS, with encryption enabled. C. Use API Gateway with Lambda, IAM for authentication, and S3 for storage. D. Use Elastic Beanstalk with an ALB, RDS, and SQS for queuing. Correct answer: A. Use API Gateway, Lambda, Cognito for authentication, and DynamoDB for storage. Explanation: API Gateway provides secure endpoints. Lambda is serverless and scales automatically. Cognito handles authentication securely. DynamoDB is a scalable and cost-effective NoSQL database with encryption. Why not other options? Option B. IAM is not suitable for user authentication in a mobile app. EC2 and RDS introduce unnecessary costs and operational overhead. Option C. IAM cannot provide user-specific authentication, and S3 is not suitable for structured API storage. Option D. Elastic Beanstalk is not ideal for unpredictable workloads. Your e-commerce platform runs in the S East 1 region using EC2 instances, RDS multi-AZ for databases, and S3 for static assets. You need to ensure disaster recovery in S West 2 with minimal RTO and RPO. Options: A. Use RDS read replica in S West 2 and replicate S3 using cross-region replication. B. Use AWS Backup to take regular snapshots and store them in S West 2. C. Use RDS multi-AZ in S West 2 and manually copy S3 objects. D. Set up CloudEndure disaster recovery for EC2 instances, enable S3 cross-region replication, and use Aurora Global Database. Correct answer: D. Set up CloudEndure disaster recovery for EC2 instances, enable S3 cross-region replication, and use Aurora Global Database. Explanation: CloudEndure enables near real-time replication of EC2 instances. S3 cross-region replication ensures static assets are available in both regions. Aurora Global Database provides low-latency read access and quick recovery. Why not other options? Option A, RDS Read Replica cannot guarantee minimal RTO without promotion delays. Option B, AWS Backup is slower compared to real-time replication. Option C, RDS Multi-AZ is not cross-region, and manual S3 copying is inefficient. Your team must regularly transfer large datasets, 10 TB+, from multiple locations worldwide to a central data lake on S3. The solution must minimize transfer time and cost. Options: A. Use AWS Snowball Edge for bulk transfers. B. Use S3 Transfer Acceleration for global high-speed uploads. C. Use AWS Data Sync with a VPN connection to AWS. D. Use Direct Connect with S3 multi-region access points. Correct answer: B. Use S3 Transfer Acceleration for global high-speed uploads. Explanation: S3 Transfer Acceleration uses AWS Global Edge locations to accelerate data uploads over long distances. Why not other options? Option A, Snowball Edge is best for offline or one-time bulk transfers, not regular transfers. Option C, Data Sync is costlier for global data movement. Option D, Direct Connect is more suitable for consistent, high-volume transfers within a specific geography. Your company operates on-premises data centers and plans to extend its architecture to AWS for a hybrid solution. The on-premises data needs to connect securely to VPCs on AWS. Options: A. Use a site-to-site VPN for secure connectivity. B. Use AWS Direct Connect with a private virtual interface. C. Use Transit Gateway to connect on-premises to AWS. D. Use VPC peering to connect on-premises data centers with AWS. Correct answer: B. Use AWS Direct Connect with a private virtual interface. Explanation: Direct Connect provides dedicated, low-latency, high-bandwidth, and secure connections for hybrid cloud setups. Why not other options? Option A, VPN is suitable for smaller workloads, but may not meet performance requirements for large data transfers. Option C, Transit Gateway connects multiple VPCs, but isn't the best option for hybrid connectivity. Option D, VPC peering is for inter-VPC communication, not for connecting on-premises networks. You need to run a high-performance computing, HPC, workload that requires low-latency communication between compute nodes and high-throughput storage. Options: A. Use EC2 instances with EBS for storage and an ALB for communication. B. Use EC2 instances in a cluster placement group with FSX for Lustre. C. Use Lambda with S3 and CloudFront for data storage. D. Use AWS Batch with S3 for storage. Correct answer: B. Use EC2 instances in a cluster placement group with FSX for Lustre. Explanation: Cluster placement groups ensure low-latency communication between EC2 instances. FSX for Lustre provides high-performance, scalable storage for HPC workloads. Why not other options? Option A, EBS lacks the required high throughput for HPC workloads. Option C, Lambda is not designed for HPC workloads, and S3 is not a high-throughput file system. Option D, AWS Batch is suitable for batch processing, not low-latency HPC tasks. Your web application is hosted on EC2 instances behind an application load balancer, ALB. During flash sales, the application experiences sudden and unpredictable traffic spikes. You need a cost-effective solution to handle traffic bursts while keeping latency low. Options: A. Increase the instance size of the EC2 instances. B. Use auto-scaling to launch additional EC2 instances based on CPU utilization. C. Migrate the application to Lambda with API Gateway. D. Use Elastic Beanstalk with Spot instances to manage the scaling automatically. Correct answer: B. Use auto-scaling to launch additional EC2 instances based on CPU utilization. Explanation: Auto-scaling ensures that additional EC2 instances are launched automatically during traffic spikes, maintaining performance while being cost-effective. Scaling based on CPU utilization is a standard metric to handle bursts effectively. Why not other options? Option A, increasing instance size is not dynamic and leads to unnecessary costs during low traffic. Option C, migrating to Lambda would require re-architecting the application, which is not feasible under immediate load conditions. Option D, Elastic Beanstalk automates management but might not offer the fine-grained control that auto-scaling provides. You manage a financial institution that needs to retain transaction logs for 7 years for compliance purposes. The logs must be easily retrievable for the first 30 days and move to a cost-effective solution afterward. Options: A. Store the logs in S3 Standard with lifecycle rules to transition to S3 Glacier Deep Archive after 30 days. B. Store the logs in S3 Standard IA and delete them after 7 years. C. Store the logs in S3 One Zone IA to reduce costs. D. Use RDS for transaction logs and enable automated backups. Correct answer: A. Store the logs in S3 Standard with lifecycle rules to transition to S3 Glacier Deep Archive after 30 days. Explanation: S3 Standard ensures durability and availability for the first 30 days when access is frequent. S3 Glacier Deep Archive provides a cost-effective solution for long-term retention with infrequent access. Why not other options? Option B, S3 Standard IA is costlier for frequent access in the first 30 days. Option C, S3 One Zone IA sacrifices durability, which is unacceptable for compliance data. Option D, RDS is designed for relational database workloads, not for cost-effective log storage. You are designing a real-time analytics system that processes clickstream data from millions of users. The system must provide low-latency writes and support SQL queries for reporting. Options: A. Use RDS MySQL with a multi-AZ configuration. B. Use DynamoDB with global secondary indexes, GSI. C. Use Amazon Redshift for real-time ingestion and querying. D. Use Amazon Aurora with a reader endpoint for analytics. Correct answer: D. Use Amazon Aurora with a reader endpoint for analytics. Explanation: Aurora provides high-performance, low-latency writes and supports SQL queries, making it ideal for real-time analytics. Reader endpoints allow horizontal scaling for read-intensive workloads. Why not other options? Option A, RDS MySQL may not scale effectively for high throughput. Option B, DynamoDB is great for low-latency writes, but does not natively support SQL queries. Option C, Redshift is optimized for OLAP, batch analytics, not real-time ingestion. You are hosting a website with static content, HTML, CSS, JS, images. The website must deliver content quickly to users globally, and access to certain files should be restricted to authenticated users. Options: A. Use S3 with public bucket policies for all files. B. Use S3 with CloudFront and signed URLs for restricted files. C. Use EC2 instances with an ALB and IAM roles for access control. D. Use S3 with lifecycle rules to delete restricted files after a specific period. Correct answer: B. Use S3 with CloudFront and signed URLs for restricted files. Explanation: S3 stores the content, and CloudFront accelerates delivery with edge locations. Signed URLs enforce restricted access for specific files. Why not other options? Option A, public bucket policies expose sensitive files. Option C, using EC2 and ALB is overengineering for static content hosting. Option D, lifecycle rules manage file deletion, not access control. Your application runs in multiple AWS regions. You need to ensure that users in different regions experience low-latency access to a central database while maintaining data consistency. Options: A. Use RDS with multi-AZ configuration. B. Use Aurora Global Database. C. Use DynamoDB with global tables. D. Use S3 with cross-region replication. Correct answer: B. Use Aurora Global Database. Explanation: Aurora Global Database replicates data across regions with sub-second latency, ensuring low-latency access and strong consistency. Why not other options? Option A, multi-AZ is only for high availability within a single region. Option C, DynamoDB global tables are great for NoSQL, but unsuitable for relational database workloads. Option D, S3 is not a database and cannot support transactional workloads. You need to migrate a large amount of on-premises data, 100 terabytes, to AWS. The migration must be completed within a week, and the data must be encrypted during transfer. Options: A. Use AWS Direct Connect with encryption enabled. B. Use AWS Snowball Edge to transfer the data physically. C. Use S3 Transfer Acceleration for faster uploads. D. Use AWS Storage Gateway to synchronize the data. Correct answer: B. Use AWS Snowball Edge to transfer the data physically. Explanation: Snowball Edge is designed for bulk data transfer, encrypts data by default, and supports terabyte-scale migrations efficiently. Why not other options? Option A, Direct Connect is not suitable for transferring 100 terabytes in a week. Option C, S3 transfer acceleration is too slow for such a large dataset. Option D, Storage Gateway is better for incremental synchronization, not bulk transfers. You are building a social media platform where users can upload photos, comment on posts, and like content. The platform must handle millions of requests per second and support low-latency data retrieval. Additionally, the database needs to be able to scale horizontally. Options: A. Use Amazon RDS with read replicas for scalability. B. Use Amazon DynamoDB with DynamoDB Accelerator, DAX. C. Use Amazon Aurora with global database enabled. D. Use Amazon Redshift for storing and querying data. Correct answer: B. Use Amazon DynamoDB with DynamoDB Accelerator, DAX. Explanation: DynamoDB is a NoSQL database designed for high throughput and low latency access, perfect for scenarios like social media platforms. DAX provides in-memory caching, reducing latency further for read-heavy workloads. Why not other options? Option A, RDS is a relational database that does not scale horizontally as efficiently as DynamoDB for NoSQL workloads. Option C, Aurora is best suited for relational data, not NoSQL. Option D, Redshift is optimized for analytics, not real-time operational queries. You are developing a RESTful API for a retail application. The API must be secure, scalable, and cost-effective. You also want to ensure that only authenticated users can access the API. Options: A. Deploy the API on EC2 instances and use IAM roles for access control. B. Use API Gateway with Lambda authorizers for authentication. C. Use ALB with EC2 instances and enforce security using security groups. D. Use AWS Elastic Beanstalk and set up custom authentication logic. Correct answer: B. Use API Gateway with Lambda authorizers for authentication. Explanation: API Gateway allows you to create and manage APIs securely. Lambda authorizers provide a serverless way to authenticate users, ensuring scalability and cost-effectiveness. Why not other options? Option A, EC2 requires more effort to scale and manage securely. Option C, ALB is not designed to manage APIs or authentication logic directly. Option D, Elastic Beanstalk requires custom development, increasing complexity unnecessarily. Your company is building a data lake to store raw data from IoT devices and process it for analytics. Data must be stored cost-effectively, and analytics queries should have low latency. Options: A. Store data in S3 Glacier and use Redshift Spectrum for querying. B. Store data in S3 Standard and use Amazon Athena for querying. C. Use S3 Intelligent Tiering and process data with Amazon EMR. D. Store data in EBS volumes and use Amazon Redshift for analytics. Correct answer: B. Store data in S3 Standard and use Amazon Athena for querying. Explanation: S3 Standard provides high durability and availability for frequently accessed data. Amazon Athena allows you to run SQL queries directly on data stored in S3, making it cost-effective and scalable. Why not other options? Option A, S3 Glacier is for archival and not optimized for frequent querying. Option C, S3 Intelligent Tiering adds cost for tiering, and EMR is overkill for simple queries. Option D, EBS is not designed for large-scale, cost-effective data storage. You are deploying a 3-tier web application on AWS. The architecture includes a front-end, an application layer, and a database layer. You need to ensure maximum security while maintaining performance. Options: A. Use security groups to control traffic between layers and expose the database to the internet for administrative access. B. Use security groups for layer communication and a NAT gateway for internet access. C. Use security groups for communication between layers and AWS Systems Manager Session Manager for database access. D. Use a single security group for all layers and manage access using IAM roles. Correct answer: C. Use security groups for communication between layers and AWS Systems Manager Session Manager for database access. Explanation: security groups provide granular control over traffic between application layers. Systems Manager Session Manager enables secure, auditable database access without exposing it to the internet. Why not other options? Option A, exposing the database to the internet is a security risk. Option B, a NAT gateway adds internet access, but does not solve the security issue for database access. Option D, using a single security group is not granular enough for secure multi-tier applications. Your company runs a critical application on AWS that must remain available during a disaster. The application is hosted in a single region with an RDS database. You need a disaster recovery solution that minimizes downtime and data loss. Options: A. Use RDS multi-AZ deployment within the same region. B. Use RDS read replicas in a different region. C. Use Aurora Global Database for cross-region replication. D. Use S3 cross-region replication to replicate the database backups. Correct answer: C. Use Aurora Global Database for cross-region replication. Explanation: Aurora Global Database replicates data across regions with minimal latency, ensuring high availability and disaster recovery. Why not other options? Option A, multi-AZ only provides high availability within the same region, not disaster recovery. Option B, read replicas provide scalability, but are not designed for disaster recovery. Option D, S3 cross-region replication replicates backups, not live databases. You run batch jobs every night to process large volumes of data. The job can be interrupted and resumed without any loss of progress. You want to minimize costs for compute resources. Options: A. Use on-demand EC2 instances. B. Use reserved instances. C. Use spot instances with a fleet configuration. D. Use Lambda functions to process the data. Correct answer: C. Use spot instances with a fleet configuration. Explanation: spot instances are significantly cheaper than on-demand instances and are suitable for interruptible workloads. Fleet configurations improve availability by diversifying instance types. Why not other options? Option A, on-demand instances are expensive for non-critical, interruptible workloads. Option B, reserved instances require a long-term commitment, which may not be flexible. Option D, Lambda has limitations on runtime and concurrent executions, making it unsuitable for large batch processing. Your company processes sensitive financial transactions and must ensure that all data transmitted between clients and the backend is encrypted. You want a cost-effective solution with minimal management overhead. Options: A. Use an application load balancer, ALB, with SSL termination. B. Use an EC2 instance to install and manage an Nginx server for SSL termination. C. Use AWS Certificate Manager, ACM, with Elastic Load Balancer. D. Use CloudHSM to manage SSL certificates and encryption keys. Correct answer: C. Use AWS Certificate Manager, ACM, with Elastic Load Balancer. Explanation: ACM simplifies SSL/TLS certificate management and integrates seamlessly with Elastic Load Balancer for cost-effective encryption in transit. Why not other options? Option A. ALB with SSL termination is valid but requires you to manually upload and manage certificates without ACM. Option B. Managing Jinx on EC2 is complex and less scalable. Option D. Cloud HSM is for advanced use cases requiring hardware security modules but is expensive and unnecessary here. You are hosting a global e-commerce platform that serves customers in multiple AWS regions. You need to route user traffic to the nearest AWS region and ensure low latency and high availability. Options: A. Use Route 53 with geolocation routing. B. Use CloudFront with S3 origin. C. Use an ALB with cross-region load balancing. D. Use Global Accelerator for routing traffic. Correct answer: D. Use Global Accelerator for routing traffic. Explanation: Global Accelerator routes user traffic to the nearest AWS region based on latency and improves performance using the AWS global network. Why not other options? Option A. Route 53 with geolocation routing works, but it doesn't optimize for latency. Option B. CloudFront caches content globally but doesn't route dynamic traffic. Option C. ALB does not support cross-region load balancing directly. Your application generates hundreds of gigabytes of log data daily. You need to store logs cost-effectively and analyze them later using SQL queries. Options: A. Store logs in S3 Standard and analyze with Amazon Redshift. B. Store logs in S3 Glacier and use Redshift Spectrum for analysis. C. Store logs in S3 Standard IA and query using Amazon Athena. D. Store logs in S3 Intelligent Tiering and use AWS Glue for data transformation. Correct answer: C. Store logs in S3 Standard IA and query using Amazon Athena. Explanation: S3 Standard IA is cost-effective for infrequent access, and Athena allows querying logs directly using SQL, reducing overall costs. Why not other options? Option A. Redshift is more expensive and designed for structured data analytics, not direct querying of raw logs. Option B. Glacier is for archival and not suitable for querying. Option D. Intelligent tiering adds cost overhead for tiering, and Glue adds unnecessary complexity for direct analysis. Your application needs to process and analyze a continuous stream of sensor data in real time, with the ability to ingest hundreds of thousands of events per second. Options: A. Use Amazon SQS with EC2 for processing messages. B. Use Amazon Kinesis data streams with AWS Lambda. C. Use DynamoDB streams with EC2 for data processing. D. Use Amazon SNS for delivering messages to subscribers. Correct answer: B. Use Amazon Kinesis data streams with AWS Lambda. Explanation: Kinesis data streams handles real-time streaming at scale, and Lambda enables serverless event processing. Why not other options? Option A. SQS is not designed for high-throughput real-time streaming. Option C. DynamoDB streams is for change data capture, not high-throughput streaming. Option D. SNS is for pub/sub messaging, not real-time event processing. You need to migrate a 10 TB on-premises Oracle database to AWS. The migration must minimize downtime and ensure data consistency. Options: A. Use AWS Database Migration Service, DMS, with an EC2 instance running Oracle. B. Use Snowball Edge for transferring data and then import to RDSC. Use AWS DMS with Amazon Aurora as the target database. D. Use S3 to upload database backups and restore them manually to an EC2 instance. Correct answer: C. Use AWS DMS with Amazon Aurora as the target database. Explanation: DMS supports continuous replication for near-zero downtime migrations, and Aurora is a fully managed database service that supports Oracle workloads. Why not other options? Option A. Running Oracle on EC2 requires more management effort and doesn't leverage Aurora's scalability. Option B. Snowball Edge is good for bulk data transfer, but doesn't provide continuous replication. Option D. Manual backup and restore introduce downtime and risk inconsistency. You are deploying a web application that must scale to handle traffic spikes while maintaining cost efficiency and availability. Options: A. Use EC2 instances with scheduled scaling. B. Use EC2 auto-scaling with elastic load balancing. C. Use AWS Lambda with provisioned concurrency. D. Use AWS Elastic Beanstalk with a fixed instance count. Correct answer: B. Use EC2 auto-scaling with elastic load balancing. Explanation: auto-scaling adjusts the number of EC2 instances based on demand, and ELB distributes traffic evenly to ensure high availability. Why not other options? Option A. Scheduled scaling doesn't respond to real-time traffic changes. Option C. Lambda is serverless, but may not suit stateful applications requiring EC2. Option D. Elastic Beanstalk with a fixed instance count cannot scale dynamically. Your company has multiple AWS accounts for different teams. Developers in one account need access to S3 buckets in another account securely. Options: A. Create IAM users in each account and assign policies. B. Use IAM roles and resource-based policies. C. Use AWS organizations with service control policies, SCPs. D. Use AWS Transfer Family for cross-account access. Correct answer: B. Use IAM roles and resource-based policies. Explanation: IAM roles enable secure cross-account access, and resource-based policies define granular access controls for S3. Why not other options? Option A. Creating IAM users increases management overhead and security risks. Option C. SCPs are used for restricting services and don't manage cross-account access directly. Option D. AWS Transfer Family is for transferring files, not cross-account access. You are building a serverless application using AWS Lambda, API Gateway, and DynamoDB. The application must authenticate users and prevent unauthorized access. Options: A. Use API Gateway with Lambda authorizers and encrypt data in DynamoDB. B. Use API Gateway with an IAM role for user authentication. C. Use Lambda environment variables to store user credentials. D. Use DynamoDB streams to validate user requests. Correct answer: A. Use API Gateway with Lambda authorizers and encrypt data in DynamoDB. Explanation: API Gateway with Lambda authorizers provides flexible, secure user authentication. Encrypting DynamoDB ensures data is protected. Why not other options? Option B. IAM roles are not intended for end-user authentication. Option C. Storing credentials and environment variables is insecure. Option D. DynamoDB streams are not designed for authentication. Your company generates large volumes of transactional data daily. The data is accessed frequently for the first 30 days, but is rarely accessed afterward. You need to archive this data in a cost-effective manner while retaining access. Options: A. Store the data in S3 Standard and configure lifecycle policies to move it to S3 Glacier after 30 days. B. Store the data in S3 Intelligent Tiering. C. Store the data in S3 Standard IA and then move it to S3 Glacier Deep Archive after 30 days. D. Store the data directly in S3 Glacier Deep Archive. Correct answer: A. Store the data in S3 Standard and configure lifecycle policies to move it to S3 Glacier after 30 days. Explanation: Storing data in S3 Standard ensures fast access during the first 30 days, and lifecycle policies automate moving data to S3 Glacier for cost-effective long-term storage. Why not other options? Option B. Intelligent tiering is more expensive for data with predictable access patterns. Option C. S3 Standard IA is less cost-effective compared to S3 Glacier for long-term storage. Option D. S3 Glacier Deep Archive is not suitable for data frequently accessed in the first 30 days. You are hosting a stateful web application on EC2. The application stores session data in memory. You need to scale the application horizontally while maintaining session consistency across instances. Options: A. Use an application load balancer, ALB, with sticky sessions. B. Use an elastic load balancer with auto-scaling. C. Use DynamoDB to store session data and distribute traffic with an ALB. D. Use Amazon Elasticache for Redis to store session data. Correct answer, D. Use Amazon Elasticache for Redis to store session data. Explanation: Elasticache for Redis provides low-latency session storage, enabling horizontal scaling while maintaining session consistency. Why not other options? Option A. Sticky sessions reduce scalability and may create uneven traffic distribution. Option B. Auto-scaling without external session storage leads to inconsistent sessions. Option C. DynamoDB is slower than Redis for session storage and not ideal for low-latency applications. Your company requires a relational database that is highly available across multiple AWS regions. The database must synchronize data between regions and automatically failover during outages. Options: A. Use Amazon RDS with multi-AZ deployment. B. Use Amazon Aurora Global Database. C. Use Amazon DynamoDB Global Tables. D. Use an EC2 instance with MySQL and configure replication across regions. Correct answer: B. Use Amazon Aurora Global Database. Explanation: Aurora Global Database replicates data across regions with low latency, providing high availability and disaster recovery. Why not other options? Option A. Multi-AZ deployment ensures high availability within a single region, not across regions. Option C. DynamoDB is NoSQL and not suitable for relational database requirements. Option D. Managing MySQL replication on EC2 adds complexity and lacks automated failover. You are managing a web application that serves users globally. Some users report high latency. You need to improve performance for all users while minimizing costs. Options: A. Use Amazon CloudFront with an S3 bucket as the origin. B. Use an application load balancer with auto-scaling. C. Use AWS Global Accelerator. D. Deploy application servers in multiple regions. Correct answer: A. Use Amazon CloudFront with an S3 bucket as the origin. Explanation: CloudFront caches content at edge locations, reducing latency for users worldwide. Why not other options? Option B. ALB only balances traffic within a region and doesn't cache content. Option C. Global Accelerator improves performance for dynamic applications but doesn't cache static content. Option D. Deploying servers globally increases operational complexity and costs. Your company requires a disaster recovery solution for an on-premises critical application. The solution must minimize downtime and data loss while being cost-effective. Options: A. Use AWS Elastic Disaster Recovery with a warm standby strategy. B. Use AWS Backup with S3 Glacier Deep Archive for data storage. C. Use AWS Storage Gateway with a tape backup solution. D. Use a multi-region active-active setup in AWS. Correct answer: A. Use AWS Elastic Disaster Recovery with a warm standby strategy. Explanation: Elastic Disaster Recovery ensures minimal downtime with a warm standby, replicating the environment in AWS for quick failover. Why not other options? Option B. S3 Glacier Deep Archive is cost-effective but has high recovery times, unsuitable for disaster recovery. Option C. Tape backup is slow and not ideal for critical applications requiring quick recovery. Option D. Multi-region active-active is highly available but significantly more expensive. You need to secure access to S3 buckets containing sensitive data. Access must be restricted to users from specific IP addresses. Options: A. Use bucket policies with IP condition keys. B. Use AWS WAF to filter IP addresses. C. Use IAM policies to allow access based on IP conditions. D. Use VPC endpoints with a security group. Correct answer: A. Use bucket policies with IP condition keys. Explanation: Bucket policies with IP condition keys restrict access at the bucket level, ensuring precise control. Why not other options? Option B. AWS WAF filters web traffic but doesn't restrict access to S3 buckets. Option C. IAM policies don't allow granular control at the IP address level for S3 access. Option D. VPC endpoints restrict access to resources within a VPC, not specific IPs. You need to build an event-driven workflow to process uploaded images. The workflow involves triggering Lambda functions to resize and watermark the images. Options: A. Use S3 event notifications to trigger AWS Lambda functions. B. Use DynamoDB streams to trigger Lambda for processing. C. Use Amazon MQ to handle the event workflow. D. Use step functions to manage the event workflow. Correct answer: A. Use S3 event notifications to trigger AWS Lambda functions. Explanation: S3 event notifications trigger Lambda functions directly upon file uploads, ideal for event-driven workflows. Why not other options? Option B. DynamoDB streams are for change data capture, not file uploads. Option C. Amazon MQ is for message brokering, adding unnecessary complexity. Option D. Step functions are suitable for complex workflows, but unnecessary here. Your company wants to migrate a monolithic on-premises application to AWS. The application has tightly coupled components and depends on local storage. The migration plan should minimize changes to the application architecture. Options: A. Use EC2 instances and attach Amazon EBS volumes for storage. B. Use Amazon ECS with Fargate and S3 for storage. C. Use AWS Lambda to host the application and DynamoDB for storage. D. Use AWS Elastic Beanstalk with S3 for storage. Correct answer: A. Use EC2 instances and attach Amazon EBS volumes for storage. Explanation: EC2 with EBS is the best fit for lift and shift migrations of monolithic applications with minimal architectural changes. Why not other options? Option B. ECS and Fargate require containerization, which may involve significant changes to the application. Option C. Lambda is unsuitable for monolithic applications because of its stateless nature and execution duration limits. Option D. Elastic Beanstalk requires decoupling the application components to leverage its platform effectively. Your company processes terabytes of data daily for analytics. Currently, the data is stored in S3, and you are using Amazon Redshift for analysis. You need to reduce costs while maintaining performance. Options: A. Use Amazon Athena to query the data directly from S3. B. Use Amazon EMR to process the data and store it in DynamoDB. C. Migrate the data to RDS and run analytics queries. D. Use Amazon Redshift Spectrum to query data directly from S3. Correct answer: D. Use Amazon Redshift Spectrum to query data directly from S3. Explanation: Redshift Spectrum allows you to query S3 data without moving it to Redshift, reducing storage costs and maintaining analytics performance. Why not other options? Option A. Athena is cost-effective but not suitable for large-scale analytics requiring advanced queries or joins. Option B. EMR with DynamoDB is expensive and less efficient for analytics workloads. Option C. RDS is not optimized for large-scale analytics and incurs higher query costs. You are designing a solution for real-time data ingestion from IoT devices. The solution must handle high throughput and store data for analytics. Options: A. Use Kinesis data streams for ingestion and Kinesis data firehose for storage. B. Use SQS for ingestion and RDS for storage. C. Use DynamoDB streams for ingestion and S3 for storage. D. Use Kafka on Amazon MSK for ingestion and store the data in DynamoDB. Correct answer: A. Use Kinesis data streams for ingestion and Kinesis data firehose for storage. Explanation: Kinesis data streams efficiently handles real-time ingestion, while Kinesis data firehose delivers the data to analytic storage like S3 or Redshift. Why not other options? Option B. SQS is not designed for real-time ingestion of high-throughput data streams. Option C. DynamoDB streams captures database changes, not real-time data ingestion. Option D. MSK is more complex to manage and incurs higher operational overhead. You are deploying an application in a VPC. The application requires access to S3 and DynamoDB without exposing the VPC to the internet. Options: A. Use a NAT gateway to enable access to S3 and DynamoDB. B. Use VPC endpoints for S3 and DynamoDB. C. Use an internet gateway with security groups. D. Use a VPN connection to access S3 and DynamoDB. Correct answer: B. Use VPC endpoints for S3 and DynamoDB. Explanation: VPC endpoints allow private connections to AWS services without needing internet access, enhancing security. Why not other options? Option A. NAT gateway requires an internet connection, increasing costs and exposure. Option C. Internet gateway exposes the VPC to the internet, violating the security requirement. Option D. A VPN is not necessary for accessing AWS services from a VPC. You are designing a web application that must handle high traffic with low latency. The application has dynamic content and requires SSL termination. Options: A. Use application load balancer with auto-scaling and enable HTTPS. B. Use CloudFront with an S3 bucket for static content and a backend EC2 instance for dynamic content. C. Use network load balancer with EC2 instances. D. Use Elastic Beanstalk with a classic load balancer. Correct answer: A. Use application load balancer with auto-scaling and enable HTTPS. Explanation: ALB supports dynamic content routing, auto-scaling for handling traffic spikes, and SSL termination for secure connections. Why not other options? Option B. CloudFront is not ideal for dynamic content requiring SSL termination. Option C. NLB doesn't support application layer routing for dynamic content. Option D. Classic load balancer is outdated and lacks modern features like dynamic routing. Your company requires a solution to synchronize data across AWS regions with minimal latency. The solution must support a relational database. Options: A. Use RDS with cross-region read replicas. B. Use Aurora Global Database. C. Use DynamoDB Global Tables. D. Use S3 cross-region replication. Correct answer: B. Use Aurora Global Database. Explanation: Aurora Global Database offers low-latency replication across regions for relational databases. Why not other options? Option A. RDS cross-region read replicas introduce higher latency and don't support multi-region writes. Option C. DynamoDB is NoSQL and not suitable for relational database use cases. Option D. S3 cross-region replication is for object storage, not databases. Your team needs to process large batches of image files uploaded to S3. Each file needs to be resized and watermarked. Options: A. Use AWS Batch to process the files. B. Use Lambda triggered by S3 events to process the files. C. Use an auto-scaling group of EC2 instances with a script to process the files. D. Use step functions with Lambda to manage the workflow. Correct answer: D. Use step functions with Lambda to manage the workflow. Explanation: Step functions manage complex workflows, coordinating Lambda functions for image resizing and watermarking. Why not other options? Option A. AWS Batch is designed for large-scale batch computing jobs, not serverless workflows. Option B. Lambda alone is insufficient for managing complex workflows. Option C. EC2 increases costs and operational overhead compared to serverless options. Your organization plans to create a data lake to store and analyze petabytes of structured and unstructured data. You need a cost-effective, scalable, and durable solution for storage and querying the data. Options: A. Use Amazon S3 for storage and Amazon Athena for querying. B. Use Amazon RDS for storage and AWS Glue for querying. C. Use Amazon DynamoDB for storage and Amazon Redshift for querying. D. Use Amazon EBS volumes attached to EC2 instances for storage and SQL queries. Correct answer: A. Use Amazon S3 for storage and Amazon Athena for querying. Explanation: S3 provides cost-effective, scalable, and durable storage for data lakes. Athena enables serverless querying of data stored in S3 using SQL. Why not other options? Option B. RDS is not suitable for unstructured data and lacks the scalability required for a data lake. Option C. DynamoDB is a NoSQL database, unsuitable for data lake use cases, and Redshift requires structured data. Option D. EBS volumes are expensive and not scalable for petabyte scale storage. You need to implement disaster recovery for a critical workload running on EC2 instances in one region. The recovery point objective, RPO, is less than 5 minutes, and the recovery time objective, RTO, is less than 1 hour. Options: A. Use AWS Backup to replicate the EC2 instance snapshots to another region. B. Use AMIs to create identical instances in another region and keep them in a stopped state. C. Use CloudFormation templates to recreate the infrastructure in another region. D. Use AWS Elastic Disaster Recovery, AWS DRS, to replicate the workload to another region. Correct answer: D. Use AWS Elastic Disaster Recovery, AWS DRS, to replicate the workload to another region. Explanation: AWS DRS replicates workloads in near real-time, ensuring minimal RPO and fast recovery, RTO. Why not other options? Option A. AWS Backup doesn't provide near real-time replication. Option B. Stopped AMIs don't meet the RPO requirement as they need to be updated frequently. Option C. CloudFormation takes time to deploy infrastructure and is not suitable for RTO under 1 hour. Your organization wants to allow EC2 instances in a private subnet to access a private S3 bucket securely without exposing the subnet to the internet. Options: A. Use a NAT gateway for internet access and configure S3 bucket policies. B. Use an internet gateway with strict security group rules. C. Use a VPC endpoint for S3. D. Use AWS Direct Connect to access S3. Correct answer: C. Use a VPC endpoint for S3. Explanation: a VPC endpoint for S3 allows private connections to S3 without internet exposure. Why not other options? Option A. A NAT gateway introduces additional costs and requires internet access. Option B. An internet gateway exposes the private subnet to the internet. Option D. Direct Connect is unnecessary for accessing S3 from the same region. Your company is migrating a 2 TB SQL database to AWS. The migration must minimize downtime and maintain schema compatibility. Options: A. Use AWS DMS to migrate the database to RDS. B. Use S3 to upload the database files and process them with Athena. C. Use DynamoDB to migrate the SQL database. D. Use AWS Snowball to transfer the database and import it to RDS. Correct answer: A. Use AWS DMS to migrate the database to RDS. Explanation: AWS DMS enables near-zero downtime migrations and supports schema compatibility. Why not other options? Option B. Athena is not designed to process relational database migrations. Option C. DynamoDB is a NoSQL database and incompatible with SQL databases. Option D. Snowball is not suitable for online, low-downtime migrations. You are designing a backend for IoT devices that send telemetry data continuously. The backend must handle millions of devices and scale automatically. Options: A. Use AWS IoT Core with DynamoDB for device data storage. B. Use EC2 instances with an auto-scaling group and RDS for storage. C. Use AWS Lambda with SQS and S3 for storage. D. Use Amazon EMR to process data in real time. Correct answer: A. Use AWS IoT Core with DynamoDB for device data storage. Explanation: AWS IoT Core is designed for scalable IoT device connectivity, and DynamoDB handles large-scale data storage. Why not other options? Option B. EC2 and RDS increase management complexity and costs for millions of devices. Option C. Lambda and SQS are not optimized for continuous, scalable IoT device connections. Option D. EMR is designed for big data processing, not IoT device connectivity. You have a static website hosted on S3. You need to deliver the content to a global audience with low latency and high performance. Options: A. Use an application load balancer in front of S3. B. Use AWS Global Accelerator with Route 53. C. Use Amazon CloudFront to distribute content. D. Use a network load balancer with EC2 instances. Correct answer: C. Use Amazon CloudFront to distribute content. Explanation: CloudFront provides a global content delivery network, CDN, with caching and low latency. Why not other options? Option A. ALB cannot cache content or improve global delivery performance. Option B. Global Accelerator does not provide CDN functionality. Option D. NLB does not improve content delivery performance for static websites. Your organization needs a hybrid cloud solution to securely connect on-premises data centers with AWS. The connection should have consistent performance and low latency. Options: A. Use a site-to-site VPN connection. B. Use AWS Direct Connect. C. Use an Internet gateway and public IPs for EC2 instances. D. Use VPC peering to connect the on-premises data center with AWS. Correct answer: B. Use AWS Direct Connect. Explanation: AWS Direct Connect provides a dedicated, low-latency, high-performance connection for hybrid cloud architectures. Why not other options? Option A. VPN connections can have inconsistent performance due to internet dependency. Option C. Internet gateways expose resources to the public internet, which is insecure. Option D. VPC peering is for connecting VPCs, not on-premises environments. You are designing a highly scalable web application that should automatically scale based on traffic demands. The application needs to support thousands of concurrent users without downtime or performance degradation. Options: A. Use EC2 instances in an auto-scaling group with elastic load balancing and Amazon RDS for data storage. B. Use Lambda functions with API Gateway for stateless processing and DynamoDB for storage. C. Use EC2 instances with elastic load balancing and Amazon S3 for static content storage. D. Use Amazon ECS with Fargate for containerized applications and Amazon Aurora for data storage. Correct answer: A. Use EC2 instances in an auto-scaling group with elastic load balancing and Amazon RDS for data storage. Explanation: Option A provides a scalable solution with EC2 instances, auto-scaling, and elastic load balancing for handling high traffic. Amazon RDS offers relational storage for dynamic data. Why not other options? Option B. Lambda and API Gateway are suitable for stateless applications, but they may not provide sufficient flexibility and performance for a large-scale web application with complex back-end interactions and session management. Option C. Using S3 for static content is appropriate for serving static assets, but it doesn't provide the dynamic scalability and back-end processing needed for the full application. Option D. ECS with Fargate is good for containerized applications, but the use of Aurora might not be necessary if simpler relational databases like RDS are sufficient, and it introduces more complexity for this scenario. Your company wants to implement a disaster recovery strategy for an application that must be available across multiple regions. The application should fail over to another region if the primary region goes down. Options: A. Use AWS Global Accelerator to route traffic to the nearest region. B. Use Amazon Route 53 with health checks to route traffic between regions. C. Use AWS Direct Connect to replicate the application in multiple regions. D. Use Amazon S3 to replicate static content between regions. Correct answer: B. Use Amazon Route 53 with health checks to route traffic between regions. Explanation: Option B enables DNS-based failover routing between regions with health checks to ensure the traffic is directed to the healthy region. Why not other options? Option A. AWS Global Accelerator is optimized for improving global application performance and routing traffic to the closest endpoint, but it doesn't directly address failover between regions for disaster recovery. Option C. Direct Connect is a dedicated network connection to AWS, but it's more for private connectivity rather than managing traffic failover between regions. Option D, S3 replication between regions is useful for static data, but it doesn't provide a solution for routing application traffic or managing failover. You are designing a system that ingests telemetry data from IoT devices. The data needs to be processed in real time, analyzed, and stored for further querying. Options: A. Use AWS IoT Core with DynamoDB for device data storage. B. Use AWS Lambda with SQS and S3 for storage. C. Use EC2 instances with autoscaling and RDS for storage. D. Use Amazon Kinesis data streams with Lambda for processing and DynamoDB for storage. Correct answer: D. Use Amazon Kinesis data streams with Lambda for processing and DynamoDB for storage. Explanation: Option D is designed for real-time streaming data processing. Kinesis provides the mechanism to ingest data, Lambda processes the data, and DynamoDB stores the data. Why not other options? Option A. While AWS IoT Core and DynamoDB work for IoT device connectivity and storage, it's less focused on real-time data processing compared to Kinesis. Option B. Lambda and SQS are good for decoupling systems but aren't optimized for continuous real-time data ingestion and analysis as Kinesis is. Option C. EC2 instances with autoscaling and RDS would require more management overhead, and using RDS for IoT data is generally less suitable for the scalability needs of real-time telemetry data. You need to ensure that your web application is highly available, with minimal downtime, in a single region. The application must have fault tolerance and be able to recover from hardware failures. Options: A. Deploy the application on EC2 instances in an auto-scaling group across multiple availability zones with an elastic load balancer. B. Deploy the application on a single EC2 instance with an elastic load balancer. C. Deploy the application on Amazon Lambda functions with API gateway. D. Deploy the application on EC2 instances with Amazon Route 53 routing. Correct answer: A. Deploy the application on EC2 instances in an auto-scaling group across multiple availability zones with an elastic load balancer. Explanation: Option A provides high availability by distributing EC2 instances across multiple availability zones and using auto-scaling to handle demand. Elastic load balancing ensures traffic is distributed across instances. Why not other options? Option B. A single EC2 instance introduces a single point of failure, and using only an elastic load balancer without multiple instances across availability zones does not ensure high availability. Option C. Lambda functions with API gateway are ideal for stateless workloads, but might not provide the same level of performance and control as EC2 for complex web applications. Option D. Route 53 routing is more useful for global DNS management rather than handling traffic balancing and failover for application-level redundancy. You need to store sensitive data, such as credit card information, and it needs to be encrypted both at rest and in transit. Which service should you use? Options: A. Use Amazon S3 with server-side encryption and HTTPS for secure transfer. B. Use Amazon RDS with encrypted storage and SSL for encrypted connections. C. Use AWS Lambda to process data and store it in DynamoDB. D. Use Amazon EFS with encryption at rest and in transit. Correct answer: B. Use Amazon RDS with encrypted storage and SSL for encrypted connections. Explanation: Option B ensures that data is encrypted at rest, with RDS encryption, and in transit, using SSL connections. Why not other options? Option A. S3 provides encrypted storage and HTTPS transfer, but it is better suited for object storage, not for managing transactional data like credit card information. Option C. While Lambda and DynamoDB can be part of a solution, they do not directly address the specific needs of encrypting sensitive transactional data at rest and in transit like RDS does. Option D. Amazon EFS offers encryption at rest and in transit, but it's typically used for shared file storage and not a relational database solution, which would be required for managing sensitive data such as credit card information. You are tasked with implementing a backup solution that stores large amounts of data at a low cost while ensuring it is easily retrievable when needed. Options: A. Use Amazon S3 with standard storage class. B. Use Amazon S3 Glacier for long-term archival storage. C. Use Amazon EBS volumes for data storage and EC2 for processing. D. Use Amazon Elastic File System, EFS, for data storage. Correct answer, B. Use Amazon S3 Glacier for long-term archival storage. Explanation, Option B offers the most cost-effective storage for long-term backup and archival data. S3 Glacier is designed for infrequent access and long-term storage at a low cost. Why not other options? Option A, S3 Standard is great for frequently accessed data but is not cost-effective for long-term backup storage where retrieval times are not urgent. Option C, EBS volumes and EC2 would be more expensive and less efficient for long-term backup storage. EBS is typically used for storing data attached to EC2 instances. Option D, Amazon EFS is designed for scalable, shared file storage, but it is more expensive than S3 Glacier for archival and backup purposes. You need to host a static website that receives high traffic volume. The website content includes images, videos, and other static files. Options: A. Use Amazon S3 with CloudFront for content delivery. B. Use EC2 instances with an auto-scaling group and S3 for static content. C. Use Lambda functions to serve static content from S3. D. Use AWS Elastic Beanstalk for hosting the static website. Correct answer, A. Use Amazon S3 with CloudFront for content delivery. Explanation, Option A is the most cost-effective and scalable solution for hosting static content. S3 provides scalable storage, and CloudFront ensures fast content delivery worldwide through its Content Delivery Network, CDN. Why not other options? Option B, using EC2 instances with auto-scaling introduces unnecessary complexity and cost, as S3 and CloudFront can serve static content efficiently. Option C, Lambda functions are not needed for serving static content from S3. CloudFront is a better solution for caching and distributing static content. Option D, Elastic Beanstalk is typically used for deploying dynamic web applications, not for hosting static websites. S3 and CloudFront are more appropriate for static content. You need to decouple the components of a microservices-based web application to allow each service to scale independently and avoid direct dependencies. Options: A. Use Amazon SQS to queue requests between services. B. Use AWS Lambda for all microservices. C. Use Amazon SNS to publish and subscribe between services. D. Use AWS step functions to coordinate microservices. Correct answer, A. Use Amazon SQS to queue requests between services. Explanation, Option A is ideal for decoupling services. SQS allows asynchronous communication, enabling services to operate independently and scale on demand. Why not other options? Option B, while AWS Lambda is great for serverless architecture, it's not always suitable for complex microservice architectures where you need message queuing and asynchronous processing. Option C, SNS is more suitable for pub/sub messaging patterns, but SQS is better for decoupling services that need to process requests asynchronously in a queue. Option D, AWS step functions is used for orchestrating workflows and service coordination, but it might be overkill when simple queuing and decoupling are needed. You are using Amazon RDS for a relational database but are experiencing high read latency during peak hours. You need to optimize the database's read performance. Options: A. Use Amazon RDS read replicas to distribute read traffic. B. Use Amazon Aurora with read scaling enabled. C. Use Amazon ElastiCache for caching frequent queries. D. Increase the instance size of the RDS database. Correct answer, A. Use Amazon RDS read replicas to distribute read traffic. Explanation, Option A allows for distributing read queries across multiple replicas, reducing the load on the primary database and improving read performance. Why not other options? Option B, Aurora's read scaling is useful, but is typically overkill when RDS read replicas can already handle the need for read scalability. Option C, ElastiCache is a good option for reducing database load by caching frequently accessed data, but read replicas are better for optimizing read-heavy database traffic. Option D. Increasing the instance size may help, but it does not address the underlying issue of distributing read traffic. Read replicas offer a more scalable solution. Your company needs to implement auto-scaling for a web application running on Amazon EC2. The application should automatically scale based on CPU utilization and should handle traffic spikes during peak hours. Options: A. Use EC2 auto-scaling with a target CPU utilization policy. B. Use Amazon Elastic Load Balancer, ELB, with multiple EC2 instances. C. Use Amazon Lambda with auto-scaling policies. D. Use EC2 auto-scaling with a fixed instance count. Correct answer: A. Use EC2 auto-scaling with a target CPU utilization policy. Explanation: Option A allows EC2 instances to automatically scale in or out based on a target CPU utilization policy, which ensures the application can handle varying levels of traffic without manual intervention. Why not other options? Option B. While ELB helps distribute traffic, it does not automatically scale EC2 instances based on CPU utilization. Auto-scaling is needed for dynamic scaling. Option C. Lambda is designed for serverless applications, not for managing EC2 instances. EC2 auto-scaling is better suited for this scenario. Option D. A fixed instance count doesn't provide flexibility to scale based on actual demand, which is essential for handling traffic spikes effectively. You need to securely transfer data between two AWS regions. The data is highly sensitive, and you must ensure it is encrypted both in transit and at rest. Options: A. Use Amazon S3 with cross-region replication and enable encryption at rest and in transit. B. Use AWS Direct Connect with encryption enabled. C. Use Amazon EC2 instances to manually transfer data between regions. D. Use AWS Snowball for transferring large datasets between regions. Correct answer: A. Use Amazon S3 with cross-region replication and enable encryption at rest and in transit. Explanation: Option A provides a secure and automated way to transfer data across regions with cross-region replication in S3, ensuring both encryption at rest and in transit. Why not other options? Option B. AWS Direct Connect provides a private connection between on-premises infrastructure and AWS, but encryption in transit requires additional configuration and is not specifically designed for transferring data between regions. Option C. EC2 instances require manual intervention, which is less scalable and introduces complexity compared to using S3 cross-region replication. Option D. AWS Snowball is ideal for physical transfers of large datasets, but is not optimized for real-time or ongoing data transfers between regions. You need to implement high availability for a multi-tier application with a web front-end, application layer, and database back-end. The application must remain operational even if an availability zone, AZ, goes down. Options: A. Deploy EC2 instances in multiple availability zones with Elastic Load Balancer and RDS Multi-AZ for database redundancy. B. Deploy EC2 instances in a single availability zone with an auto-scaling group and an RDS instance. C. Deploy EC2 instances in multiple availability zones and use Amazon DynamoDB for the database layer. D. Deploy EC2 instances in multiple availability zones with S3 for the database. Correct answer: A. Deploy EC2 instances in multiple availability zones with Elastic Load Balancer and RDS Multi-AZ for database redundancy. Explanation: Option A provides high availability by distributing EC2 instances across multiple availability zones. The Elastic Load Balancer ensures traffic distribution, and RDS Multi-AZ guarantees database redundancy and failover capabilities. Why not other options? Option B. A single availability zone creates a single point of failure. RDS Multi-AZ should be used with multiple availability zones for high availability. Option C. DynamoDB is a great NoSQL database, but for relational database needs, RDS is more appropriate for a multi-tier application architecture. Option D. S3 is an object storage service and is not designed for transactional or relational database storage. RDS is the right choice for database redundancy. Your development team needs to set up multiple environments for testing and staging purposes. The environments should be cost-effective and should only run when necessary, automatically shutting down when not in use. Options: A. Use EC2 instances with auto-scaling and schedule the instances to stop during off hours. B. Use EC2 spot instances to run development environments. C. Use Amazon Lightsail for all development environments. D. Use AWS Elastic Beanstalk with auto-scaling for all environments. Correct answer: B. Use EC2 spot instances to run development environments. Explanation: Option B provides a highly cost-effective solution for development environments. EC2 spot instances allow you to take advantage of unused EC2 capacity at a significantly lower cost than on-demand instances. Why not other options? Option A: While scheduling EC2 instances to stop during off hours can reduce costs, spot instances are more cost-effective than on-demand instances for non-critical workloads. Option C: Amazon Lightsail is ideal for simple workloads, but may not offer the flexibility required for complex development environments. Option D: Elastic Beanstalk is a PaaS solution that automatically handles application deployment, but it may not be as cost-effective as using spot instances for development environments. You need to grant a specific set of users secure access to an S3 bucket, but you want to ensure they cannot access any other resources in your AWS environment. Options: A. Use an S3 bucket policy to allow access based on specific IAM user conditions. B. Use IAM roles to provide access to the S3 bucket. C. Use AWS KMS to encrypt the S3 bucket and restrict access to encrypted objects. D. Use Amazon CloudFront with signed URLs to restrict access to the S3 bucket. Correct answer: A. Use an S3 bucket policy to allow access based on specific IAM user conditions. Explanation: Option A allows you to control access to the S3 bucket using fine-grained permissions based on IAM users, ensuring that only the specified users can access the resources. Why not other options? Option B: IAM roles are used to grant permissions to entities like EC2 instances or Lambda functions, not directly to specific users. While IAM roles can be used in conjunction with bucket policies, Option A is a more direct solution. Option C: AWS KMS encryption ensures data is protected, but it doesn't directly address access control based on IAM users or conditions. Bucket policies are more appropriate for controlling access. Option D: CloudFront with signed URLs is used to control access to S3 objects via distribution, but bucket policies provide more straightforward access control for a specific set of IAM users. Your company runs a global e-commerce website hosted in the AWS cloud. The website needs to provide low-latency access to users from different geographic locations, including Asia, Europe, and North America. You want to optimize content delivery and minimize latency for all users. Options: A. Use Amazon S3 with CloudFront for caching and content delivery. B. Use Amazon EC2 instances in each region and configure cross-region replication for the data. C. Use AWS Global Accelerator to direct users to the closest available region and deploy the web application across multiple regions. D. Use Elastic Load Balancer with multiple availability zones in one region. Correct answer: C. Use AWS Global Accelerator to direct users to the closest available region and deploy the web application across multiple regions. Explanation: Option C uses AWS Global Accelerator, which optimizes the path to your application by directing users to the nearest healthy AWS endpoint, ensuring low-latency access for global traffic. Why not other options? Option A: While S3 and CloudFront can deliver content effectively for static assets, Global Accelerator is better for dynamic content and ensuring the lowest latency by routing traffic to the closest region. Option B: Managing EC2 instances in each region can increase complexity and cost. Cross-region replication is typically used for data but doesn't optimize for low-latency access globally. Option D: ELB with multiple AZs in one region does not offer a global solution. It is more suitable for high availability within a specific region, not for optimizing global traffic. Your company needs to implement a disaster recovery (DR) solution for its application that runs in an AWS region. The solution should ensure business continuity in the event of a regional failure, with minimal data loss and downtime. Options: A. Use Amazon RDS multi-AZ deployment and implement an S3 bucket for cross-region replication. B. Use Amazon EC2 instances in an auto-scaling group with S3 backup for data storage. C. Use Amazon Route 53 with health checks to redirect traffic to a secondary region in the event of failure. D. Use AWS Elastic Beanstalk with multiple environments in different regions. Correct answer: A. Use Amazon RDS multi-AZ deployment and implement an S3 bucket for cross-region replication. Explanation: Option A offers a comprehensive solution. RDS multi-AZ ensures database failover in case of regional failure, and cross-region S3 replication ensures that critical data is available in a backup region. Why not other options? Option B, EC2 auto-scaling and S3 backup don't provide the database-level resilience needed for disaster recovery. Multi-AZ RDS is more appropriate for database continuity. Option C, Route 53 can help with failover, but without multi-AZ or cross-region replication for databases and other critical data, it won't ensure full business continuity. Option D, Elastic Beanstalk with multiple environments may help with scaling but doesn't provide the database replication and backup strategy necessary for a true disaster recovery solution. You need to deploy a serverless application that processes data when events occur. The application must scale automatically and only incur costs when processing events. Additionally, the application should integrate with other AWS services to store data and handle notifications. Options: A. Use AWS Lambda with API Gateway, Amazon S3, and Amazon SNS. B. Use AWS Elastic Beanstalk with an auto-scaling group and an S3 bucket. C. Use EC2 instances with an auto-scaling group and S3 for data storage. D. Use Amazon ECS with Fargate and Amazon SNS for notifications. Correct answer: A. Use AWS Lambda with API Gateway, Amazon S3, and Amazon SNS. Explanation: Option A provides a fully serverless solution. AWS Lambda automatically scales based on events, API Gateway handles the HTTP requests, S3 stores the data, and SNS manages notifications. This is a cost-effective and scalable architecture. Why not other options? Option B, Elastic Beanstalk is not fully serverless. It involves EC2 instances and requires management of scaling and infrastructure. Lambda is more suitable for event-driven serverless applications. Option C, EC2 instances are not needed for a serverless application. Lambda is more efficient and cost-effective for event-driven workloads. Option D, Amazon ECS with Fargate is serverless for containerized applications, but Lambda is simpler and more cost-effective for processing events in real time. You have a web application running in a private subnet within a VPC. You need to securely allow users from the internet to access the application without exposing the application servers directly to the public internet. Options: A. Use an application load balancer, ALB, with SSL termination and configure a security group to allow access. B. Use a VPN connection to allow users to access the application. C. Use a bastion host to provide secure access to the private subnet. D. Use AWS Direct Connect to provide access to the application. Correct answer: A. Use an application load balancer, ALB, with SSL termination and configure a security group to allow access. Explanation: Option A allows secure access to your application through an ALB, with SSL termination to ensure encrypted communication. The ALB can route traffic to private subnets, ensuring security without exposing the application servers. Why not other options? Option B, a VPN connection is not necessary for allowing general internet access to your application. It's more suited for private, secure communication between on-premises networks and AWS. Option C, a bastion host is used to manage access to instances in a private subnet but is not ideal for direct application access. ALB is better suited for routing user traffic. Option D. AWS Direct Connect is a private connection between on-premises and AWS, typically used for low-latency, high-bandwidth applications. It's not designed for public access to a web application. Your company needs to set up a data lake to store structured and unstructured data from various sources. The solution should be scalable, cost-effective, and allow analysts to query the data without requiring complex ETL processes. Options: A. Use Amazon S3 for storage, AWS Glue for ETL, and Amazon Athena for querying data. B. Use Amazon RDS for storing structured data and Amazon Redshift for unstructured data. C. Use Amazon DynamoDB for storing structured data and Amazon S3 for unstructured data. D. Use Amazon EFS for data storage and Amazon EMR for processing data. Correct answer: A. Use Amazon S3 for storage, AWS Glue for ETL, and Amazon Athena for querying data. Explanation: Option A provides a scalable and cost-effective solution for a data lake. Amazon S3 stores data, AWS Glue helps in ETL tasks, and Amazon Athena allows for querying data directly in S3 without the need for complex ETL processes. Why not other options? Option B. RDS and Redshift are not designed for unstructured data storage, and their pricing model is not suitable for storing large amounts of raw data. Option C. DynamoDB is a NoSQL database, but it's not intended for storing large, unstructured data. S3 is more suitable for unstructured data, while Glue and Athena are the better tools for ETL and querying. Option D. EFS is more suitable for shared file storage, but S3 is a better choice for a data lake. EMR is used for big data processing, not for building a data lake. You are tasked with securing access to a MySQL database hosted in Amazon RDS. Only authorized applications should be able to connect to the database, and you want to ensure that connections are encrypted. Options: A. Enable SSL for RDS, use IAM roles to control access, and configure security groups for network access control. B. Use AWS KMS to encrypt the database and configure an IAM policy for access control. C. Use Amazon CloudFront to secure the database and restrict access with signed URLs. D. Use AWS WAF to protect the database from unauthorized access. Correct answer: A. Enable SSL for RDS, use IAM roles to control access, and configure security groups for network access control. Explanation: Option A provides a secure solution by using SSL for encrypted communication to the database, IAM roles to manage access, and security groups to control network-level access. Why not other options? Option B. While AWS KMS can encrypt data at rest, it does not directly address secure network access or connection encryption. IAM policies are not a direct solution for controlling database access to MySQL and RDS. Option C. CloudFront is a content delivery network and not used to secure database access. Signed URLs are used for securing access to content, not databases. Option D. AWS WAF protects web applications from malicious traffic, but it doesn't address database-level access control or encryption requirements. You have a data processing application running on EC2 instances that processes large files stored in S3. The application runs periodically and requires significant computing power only during processing time. You need to reduce costs while still providing sufficient compute resources when needed. Options: A. Use Amazon EC2 spot instances to reduce costs. B. Use Amazon EC2 reserved instances for the compute capacity. C. Use AWS Lambda with S3 triggers to process files when they are uploaded. D. Use Amazon Elastic MapReduce, EMR, for processing large files. Correct answer: A. Use Amazon EC2 spot instances to reduce costs. Explanation: Option A is the most cost-effective solution. Spot instances provide unused EC2 capacity at a much lower cost, making them ideal for applications that can tolerate interruptions and run only when needed. Why not other options? Option B. Reserved instances provide cost savings for long-term usage, but are not suitable for applications that only require compute power periodically. Option C. AWS Lambda is a good choice for serverless applications, but it might not be the best fit for processing large files, especially if the processing requires significant compute power or longer execution times. Option D, EMR is ideal for big data processing, but may introduce additional complexity and cost compared to spot instances for simple file processing tasks. Your company's web application is running on EC2 instances in a single availability zone. You need to implement high availability for the web application, ensuring that it remains operational even if an availability zone goes down. Options: A. Use an elastic load balancer, ELB, with EC2 instances in multiple availability zones. B. Use EC2 auto-scaling with instances in a single availability zone and ELB for traffic distribution. C. Use Amazon Route 53 with health checks to direct traffic to another region in the event of failure. D. Use AWS Global Accelerator to route traffic to the nearest available region and deploy EC2 instances in multiple regions. Correct answer: A. Use an elastic load balancer, ELB, with EC2 instances in multiple availability zones. Explanation: Option A ensures high availability by distributing EC2 instances across multiple availability zones and using an elastic load balancer, ELB, to balance the traffic between them. Why not other options? Option B. While EC2 auto-scaling helps with scaling, deploying instances in only one availability zone does not provide high availability. Option C. Route 53 health checks can help with failover to a different region, but it's more complex and may result in higher latency compared to using multiple availability zones within the same region. Option D. AWS Global Accelerator routes traffic to the closest available region, but using it for a simple web application with high availability needs within a region adds unnecessary complexity. You have a web application running on EC2 instances in an auto-scaling group. The scaling policies need to be based on custom application-level metrics, e.g. request count per second, instead of just CPU utilization. You want to implement this efficiently. Options: A. Use Amazon CloudWatch to create custom metrics for the application and set up auto-scaling policies based on those metrics. B. Use AWS X-Ray to track application performance and automatically scale EC2 instances. C. Use Amazon EC2 auto-scaling with scheduled scaling based on application usage patterns. D. Use AWS Lambda to automatically adjust the number of EC2 instances based on custom metrics. Correct answer: A. Use Amazon CloudWatch to create custom metrics for the application and set up auto-scaling policies based on those metrics. Explanation: Option A allows you to create custom CloudWatch metrics, which can be used as the basis for auto-scaling policies. This provides the most flexible and scalable solution for application-specific scaling. Why not other options? Option B. AWS X-Ray is useful for tracing application requests and performance, but it doesn't directly integrate with auto-scaling for adjusting instance counts based on custom metrics. Option C. Scheduled scaling is based on time and usage patterns but doesn't dynamically respond to real-time metrics like request count per second. Option D. AWS Lambda can automate many tasks but isn't designed to directly adjust the size of an auto-scaling group based on application metrics. CloudWatch provides a more integrated solution. You need to secure access from an EC2 instance to an S3 bucket. The instance should only be able to access the bucket and no other AWS resources, and you want to ensure that access is done using the most secure method. Options: A. Attach an IAM role to the EC2 instance that grants access to the S3 bucket. B. Use a security group to control access from the EC2 instance to the S3 bucket. C. Use an IAM user with access keys stored on the EC2 instance for S3 access. D. Use AWS KMS to grant the EC2 instance access to the S3 bucket using encryption. Correct answer: A. Attach an IAM role to the EC2 instance that grants access to the S3 bucket. Explanation: Option A is the most secure and recommended approach. Attaching an IAM role to the EC2 instance allows for fine-grained access control using policies, and the instance can securely access the S3 bucket without the need for credentials being stored on the instance. Why not other options? Option B. Security groups control network access, but don't provide access control for AWS resources like S3. Option C. Storing IAM user credentials on the EC2 instance is not a recommended practice. IAM roles provide a more secure and scalable approach. Option D. AWS KMS is used for encrypting data, but is not designed to provide access control for an EC2 instance to an S3 bucket. IAM roles are the correct way to manage access permissions. You need to deploy a scalable web application that provides low-latency responses to users in multiple regions worldwide. The application should be able to scale automatically based on demand and provide fast content delivery to users globally. Options: A. Use Amazon CloudFront with S3 for content delivery and EC2 auto-scaling to handle application load. B. Use Amazon Route 53 with health checks to route users to the nearest region, and deploy EC2 instances in multiple regions. C. Use Amazon Elastic Load Balancer, ELB, with instances in a single region and enable cross-region replication for data storage. D. Use AWS Global Accelerator to route users to the closest region, and use EC2 instances in a single region. Correct answer: A. Use Amazon CloudFront with S3 for content delivery and EC2 auto-scaling to handle application load. Explanation: Option A optimizes content delivery using CloudFront, a global content delivery network, CDN, while EC2 auto-scaling ensures the application scales based on demand. S3 can store static content for fast access. Why not other options? Option B. Route 53 with health checks can help with routing traffic based on regional health but does not provide a full content delivery and scaling solution like CloudFront and auto-scaling. Option C. ELB in one region is not ideal for handling global traffic. Cross-region replication of data adds complexity and increases latency. Option D. Global Accelerator routes traffic but does not manage content delivery or automatically scale application load in the region itself. Your company needs a cost-effective solution for backing up large amounts of data generated by a web application. The backup solution should be durable, scalable, and easily accessible for recovery in case of failure. However, you want to minimize costs for storing data that is not frequently accessed. Options: A. Use Amazon S3 Glacier for long-term data storage and S3 lifecycle policies to transition infrequently accessed data to Glacier. B. Use Amazon EBS snapshots to back up data and store them in a standard S3 bucket. C. Use AWS Backup to create backup plans for data stored in RDS and EBS. D. Use EC2 instances with manual backup scripts to copy data to S3 on a schedule. Correct answer: A. Use Amazon S3 Glacier for long-term data storage and S3 lifecycle policies to transition infrequently accessed data to Glacier. Explanation: Option A offers a cost-effective solution for long-term, infrequent data access by using S3 Glacier for cold storage and automating the data transition with S3 lifecycle policies. This reduces costs for storing backups. Why not other options? Option B. EBS snapshots are good for EC2 volumes, but not designed for cost-effective long-term backup solutions. Standard S3 storage is more expensive than Glacier for infrequently accessed data. Option C. AWS Backup provides backup for managed services like RDS and EBS, but is not as cost-efficient for large amounts of data, especially when compared to Glacier. Option D. Manual EC2 backups require extra management and are not as automated or cost-effective as using Glacier for long-term storage. Your team needs to implement a CI/CD pipeline for deploying code changes to an application hosted on EC2 instances. The pipeline should automate the build, test, and deployment process, and you want it to be fully integrated with AWS services. Options: A. Use AWS Code Pipeline, AWS Code Build, and AWS Code Deploy to automate the CI/CD process. B. Use AWS Lambda with S3 for versioning code, and deploy using EC2 auto-scaling. C. Use AWS CloudFormation to automate deployments, combined with S3 for storage of the application code. D. Use Amazon EC2 instances with Jenkins and integrate with GitHub for version control. Correct answer: A. Use AWS Code Pipeline, AWS Code Build, and AWS Code Deploy to automate the CI/CD process. Explanation: Option A is the best solution for CI/CD. AWS Code Pipeline automates the entire pipeline, while Code Build handles the build process, and Code Deploy manages the deployment of the application to EC2 instances. Why not other options? Option B, AWS Lambda and S3 are not ideal for managing a CI/CD pipeline, especially for build and deployment stages. Lambda works for serverless applications, but lacks CI/CD integration. Option C, CloudFormation automates infrastructure provisioning but is not designed specifically for CI/CD workflows. S3 is used for storage, but not for deployment automation. Option D, Jenkins is a third-party solution that requires manual setup and management, while AWS native services like Code Pipeline provide a more integrated, fully managed solution. Your company wants to migrate an on-premises MySQL database to AWS with minimal downtime. The migration should ensure that the database is fully synchronized between the on-premises system and AWS during the migration process. Options: A. Use AWS Database Migration Service, DMS, to replicate the database from on-premises to RDS MySQL with minimal downtime. B. Perform a manual export of the MySQL database to S3 and import it into Amazon RDS-C. Use AWS Snowball to transfer the MySQL database to Amazon S3, and then import it into RDS-D. Use Amazon Aurora with MySQL compatibility, and manually copy the data to Aurora. Correct answer: A. Use AWS Database Migration Service, DMS, to replicate the database from on-premises to RDS MySQL with minimal downtime. Explanation: Option A is the ideal solution. AWS DMS allows for continuous data replication from an on-premises MySQL database to Amazon RDS MySQL with minimal downtime, making it perfect for live migrations. Why not other options? Option B, manually exporting and importing the database is error-prone and will cause significant downtime during the process, making it unsuitable for a live migration. Option C, AWS Snowball is used for large data transfers but is not suitable for real-time data replication, which is necessary for minimal downtime migrations. Option D, Aurora is compatible with MySQL but doesn't provide an automatic mechanism for migrating an on-premises MySQL database with minimal downtime. DMS is better suited for this purpose. Your company is deploying a web application in AWS. The application needs to be hosted in a private subnet for security reasons, but it also needs to interact with services like RDS and S3. You want to ensure that only the web application can access these services, while external access is restricted. Options: A. Use a VPC with private and public subnets, place the web application in the private subnet, and use VPC endpoints for secure access to S3 and RDS. B. Place the web application in a public subnet with a security group that restricts traffic to S3 and RDS. C. Use a direct connect connection from on-premises to AWS for secure access to S3 and RDS-D. Place the web application in an auto-scaling group in a public subnet and use security groups to control access. Correct answer: A. Use a VPC with private and public subnets, place the web application in the private subnet, and use VPC endpoints for secure access to S3 and RDS. Explanation: Option A provides a secure and scalable architecture. The web application is hosted in a private subnet, ensuring it is not directly accessible from the internet, while VPC endpoints allow secure access to S3 and RDS without needing a NAT gateway or public IP addresses. Why not other options? Option B, placing the web application in a public subnet exposes it to the internet. This goes against the requirement of keeping the application secure in a private subnet. Option C, AWS Direct Connect is used for private connectivity between on-premises and AWS. It is unnecessary for accessing services like S3 and RDS within the AWS cloud. Option D, hosting the application in a public subnet with an auto-scaling group exposes it to external traffic, making it less secure. You manage an application using Amazon DynamoDB as the database. Your business requires a multi-region disaster recovery solution with active-active replication to ensure low-latency reads and writes globally. Options: A. Use DynamoDB global tables. B. Use DynamoDB streams with Lambda to replicate data to another region. C. Use AWS DMS to replicate data between DynamoDB tables in different regions. D. Use S3 cross-region replication to store the data from DynamoDB tables. Correct answer: A. Use DynamoDB global tables. Explanation: DynamoDB global tables provide a fully managed, multi-region, and active-active replication solution, ensuring low-latency reads/writes. Why not other options? Option B. DynamoDB streams with Lambda requires custom code and doesn't provide true active-active replication. Option C. AWS DMS isn't designed for real-time replication with active-active requirements. Option D. S3 cross-region replication doesn't apply to DynamoDB use cases and won't ensure consistency. You have a monolithic application hosted on EC2 instances and want to migrate to a microservices architecture. The migration should minimize downtime and provide an easy way to manage the lifecycle of microservices. Options: A. Use AWS Elastic Beanstalk to host microservices. B. Use Amazon ECS with EC2 launch type. C. Use Amazon EKS with Fargate. D. Use AWS Lambda with API Gateway. Correct answer: C. Use Amazon EKS with Fargate. Explanation: EKS, Elastic Kubernetes Service, with Fargate provides a scalable, containerized platform to manage microservices without managing servers. Why not other options? Option A. Elastic Beanstalk is not ideal for fine-grained microservice deployments. Option B. ECS with EC2 launch type requires you to manage the EC2 instances. Option D. Lambda with API Gateway works for serverless microservices, but may not be ideal for migrating large monolithic applications. Your organization must archive 10 terabytes of financial data for compliance purposes. The data will rarely be accessed, but must be retained for 10 years at the lowest cost. Options: A. Store data in S3 standard with versioning enabled. B. Use S3 Glacier Deep Archive. C. Use Amazon EFS with lifecycle policies. D. Use RDS to store the data in a database. Correct answer: B. Use S3 Glacier Deep Archive. Explanation: S3 Glacier Deep Archive is the most cost-effective solution for long-term, rarely accessed data. Why not other options? Option A. S3 standard is too expensive for archival storage. Option C. EFS is designed for file system use cases, not archival storage. Option D. RDS is costly and unnecessary for data that is rarely queried. You are running a web application on EC2 instances behind an application load balancer. The traffic to the application is spiky, with unpredictable peaks. Options: A. Use reserved instances for the EC2 instances. B. Use spot instances with auto-scaling. C. Use on-demand instances with auto-scaling. D. Use auto-scaling with a mix of on-demand and spot instances. Correct answer: D. Use auto-scaling with a mix of on-demand and spot instances. Explanation: a mix of on-demand and spot instances ensures cost savings while maintaining availability during traffic spikes. Why not other options? Option A. Reserved instances don't provide flexibility for spiky workloads. Option B. Spot instances alone may lead to interruptions during high demand. Option C. On-demand instances are costlier without leveraging spot instances. You are storing sensitive customer data in Amazon RDS. The company requires encryption for all data at rest, including backups and snapshots. Options: A. Enable RDS encryption at the database level during instance creation. B. Use AWS KMS to encrypt the EBS volumes attached to the RDS instance. C. Use SSL/TLS to encrypt connections to the database. D. Use AWS Cloud HSM to encrypt the RDS instance. Correct answer: A. Enable RDS encryption at the database level during instance creation. Explanation: RDS encryption at the database level ensures that all data, including backups and snapshots, is encrypted automatically. Why not other options? Option B: KMS encryption of EBS volumes doesn't cover RDS backups and snapshots. Option C: SSL/TLS encrypts data in transit, not at rest. Option D: Cloud HSM is more complex and unnecessary for RDS encryption use cases. You manage multiple AWS accounts for your organization and need a centralized solution to enforce IAM permissions across all accounts. Options: A. Use AWS organizations with SCPs, service control policies. B. Create separate IAM users in each account and assign policies. C. Use AWS IAM Identity Center, AWS Single Sign-On. D. Use cross-account IAM roles for each account. Correct answer: A. Use AWS organizations with SCPs, service control policies. Explanation: AWS organizations with SCPs allow centralized control over permissions across multiple accounts. Why not other options? Option B: Managing IAM users separately in each account increases complexity. Option C: IAM Identity Center is suitable for single sign-on but not for enforcing SCPs. Option D: Cross-account roles don't provide centralized policy enforcement. You need to process real-time data streams from IoT devices, generating millions of events per second. The solution must scale automatically and handle failures. Options: A. Use Amazon Kinesis data streams with AWS Lambda. B. Use SQS with EC2 instances for processing. C. Use DynamoDB streams for real-time data ingestion. D. Use Amazon EMR for processing the streams. Correct answer: A. Use Amazon Kinesis data streams with AWS Lambda. Explanation: Kinesis data streams handles real-time, high-throughput data ingestion, and Lambda ensures serverless, fault-tolerant processing. Why not other options? Option B: SQS doesn't support real-time streaming data. Option C: DynamoDB streams is not designed for high-throughput ingestion. Option D: EMR is optimized for batch processing, not real-time streams. Your organization stores log data in Amazon S3 in various formats: CSV, JSON, Parquet. The team needs to run SQL queries directly on this data without moving it, while keeping costs low. Options: A. Use AWS Glue to transform the data and store it in an RDS instance. B. Use Amazon EMR with Spark to query the data. C. Use Amazon Athena to query the data directly from S3. D. Use Redshift Spectrum to query the data. Correct answer: C. Use Amazon Athena to query the data directly from S3. Explanation: Athena is a serverless, pay-per-query service specifically designed to query structured or unstructured data stored in S3. Why not other options? Option A: AWS Glue is for ETL and not optimal for querying data directly. Option B: Amazon EMR is costlier and more complex for ad hoc queries. Option D: Redshift Spectrum requires provisioning a Redshift cluster, which adds unnecessary cost. You are running containerized applications on Amazon ECS using the Fargate launch type. The containers need shared storage to persist state across multiple tasks. Options: A. Use Amazon S3 to store shared data. B. Use Amazon EFS as a shared file system. C. Use instant store volumes. D. Use DynamoDB for storing shared state. Correct answer: B. Use Amazon EFS as a shared file system. Explanation: Amazon EFS provides a managed, scalable file system that is ideal for shared storage across ECS tasks. Why not other options? Option A: S3 doesn't support file system semantics required by shared storage. Option C: instant store volumes are ephemeral and don't persist data across tasks. Option D: DynamoDB is designed for structured data, not file storage. You have a public-facing web application hosted on EC2 instances. The application needs protection from DDoS attacks and must allow only HTTPS traffic. Options: A. Use Network Load Balancer with AWS Shield Advanced. B. Use CloudFront with AWS WAF and AWS Shield Standard. C. Use an application load balancer with security groups. D. Use Route 53 with a custom DNS firewall. Correct answer, B. Use CloudFront with AWS WAF and AWS Shield Standard. Explanation: CloudFront distributes traffic globally, reducing the attack surface. AWS WAF provides Layer 7 filtering, and Shield Standard offers basic DDoS protection. Why not other options? Option A, Network Load Balancer doesn't provide Layer 7 filtering or DDoS mitigation. Option C, security groups don't protect against DDoS attacks. Option D, Route 53 DNS firewalls are not designed for application layer protection. Your company wants to build a data warehouse for structured and semi-structured data, while scaling automatically to handle seasonal spikes. Options: A. Use DynamoDB for the data warehouse. B. Use Amazon Aurora with partition tables. C. Use Amazon Redshift with Spectrum for querying S3 data. D. Use Amazon RDS with RED replicas. Correct answer: C. Use Amazon Redshift with Spectrum for querying S3 data. Explanation: Redshift is purpose-built for data warehousing, and Redshift Spectrum can directly query semi-structured data stored in S3. Why not other options? Option A, DynamoDB is for NoSQL workloads, not data warehousing. Option B, Aurora doesn't scale as well as Redshift for large analytical queries. Option D, RDS with RED replicas is better suited for OLTP, not OLAP workloads. Your team manages a fleet of EC2 instances. You want to automate OS patching across all instances with minimal manual intervention. Options: A. Use AWS config with patch rules. B. Use Systems Manager, Patch Manager. C. Use an auto-scaling group to replace unpatched instances. D. Use CloudFormation to enforce patch compliance. Correct answer: B. Use Systems Manager, Patch Manager. Explanation: Systems Manager Patch Manager automates the process of applying patches across EC2 instances. Why not other options? Option A, AWS config tracks compliance, but doesn't automate patching. Option C, auto-scaling doesn't handle OS patching. Option D, CloudFormation is for infrastructure as code, not operational management. You are designing a solution for IoT devices sending temperature data in real time. The data must be processed and stored for analytics. Options: A. Use Amazon Kinesis data streams for ingestion and DynamoDB for storage. B. Use AWS IoT Core for ingestion and S3 for storage. C. Use SQS for ingestion and Aurora for storage. D. Use Kafka on EC2 instances for ingestion and Redshift for storage. Correct answer: B. Use AWS IoT Core for ingestion and S3 for storage. Explanation: AWS IoT Core is purpose-built for IoT data ingestion. Storing the data in S3 is cost-effective for analytics. Why not other options? Option A, Kinesis data streams isn't optimized for IoT use cases like AWS IoT Core. Option C, SQS doesn't handle real-time IoT streaming. Option D, managing Kafka on EC2 is complex compared to fully managed IoT Core. Your application has global users and requires low-latency read operations in different AWS regions. Options: A. Use multi-AZ deployments for Amazon RDS. B. Use DynamoDB global tables. C. Use Amazon RDS read replicas in multiple regions. D. Use ElastiCache with cross-region replication. Correct answer: C. Use Amazon RDS read replicas in multiple regions. Explanation: RDS read replicas allow read operations to be offloaded, reducing latency for global users. Why not other options? Option A, multi-AZ is for high availability, not performance optimization. Option B, DynamoDB global tables apply to NoSQL workloads, not RDS. Option D, ElastiCache is for in-memory caching, not database replication. Your company has a mission-critical application running in the US East 1 region, and you need to ensure minimal downtime in case of a complete regional outage. The solution must also be cost-effective. Options: A. Use an active-active architecture across two AWS regions with Route 53 latency-based routing. B. Use an active-passive architecture with a warm standby in another AWS region. C. Use an active-active setup using multiple availability zones in a single AWS region. D. Use Amazon CloudFront with an S3 origin configured for cross-region replication. Correct answer: B. Use an active-passive architecture with a warm standby in another AWS region. Explanation: active-passive with a warm standby is a cost-effective disaster recovery strategy where a secondary region is partially scaled and ready to scale up during a failover. Why not other options? Option A. Active-active is expensive due to maintaining full infrastructure in multiple regions. Option C. Active-active across multiple AZs doesn't address a regional outage. Option D. CloudFront with cross-region replication is suitable for static content but not for mission-critical applications requiring low downtime. You have multiple AWS accounts, and your team in account A needs to access specific S3 buckets in account B securely without exposing data publicly. Options: A. Enable public access on the S3 buckets in account B. B. Use AWS organizations to share the S3 bucket directly. C. Configure an S3 bucket policy with cross-account permissions in account B. D. Use Amazon CloudFront with signed URLs for access. Correct answer: C. Configure an S3 bucket policy with cross-account permissions in account B. Explanation: bucket policies can specify cross-account permissions to allow users or roles from another account to access resources securely. Why not other options? Option A. Public access exposes the bucket to everyone, which is insecure. Option B. AWS organizations doesn't handle resource-level permissions directly. Option D. CloudFront signed URLs are for temporary access to content, not ongoing cross-account access. You are designing a serverless data processing pipeline. Data from IoT sensors is sent every second, processed in real time, and stored in a data lake for analytics. Options: A. Use Kinesis data streams for ingestion, AWS Lambda for processing, and S3 for storage. B. Use SQS for ingestion, EC2 for processing, and RDS for storage. C. Use DynamoDB streams for ingestion, AWS Glue for processing, and S3 for storage. D. Use Amazon MQ for ingestion, Lambda for processing, and DynamoDB for storage. Correct answer: A. Use Kinesis data streams for ingestion, AWS Lambda for processing, and S3 for storage. Explanation: Kinesis data streams is designed for real-time streaming data ingestion. AWS Lambda can process the data in real time, and S3 is cost-effective for storing large-scale data lakes. Why not other options? Option B. SQS isn't designed for real-time streaming, and using EC2 adds complexity and costs. Option C. DynamoDB streams is for changes to DynamoDB tables, not general streaming. Option D. Amazon MQ is for traditional message brokers and isn't optimized for high-throughput streaming. Your e-commerce application requires a relational database with high availability, automatic backups, and failover across multiple availability zones. Options: A. Use Amazon RDS in a single AZ deployment. B. Use Amazon Aurora with multi-AZ enabled. C. Use Amazon Redshift with automated backups. D. Use DynamoDB with on-demand backup enabled. Correct answer: B. Use Amazon Aurora with multi-AZ enabled. Explanation: Amazon Aurora Multi-AZ provides high availability, automated backups, and automatic failover across multiple AZs. It's optimized for performance and scalability. Why not other options? Option A. Single AZ deployment lacks failover and high availability. Option C. Redshift is a data warehouse, not a transactional database for e-commerce. Option D. DynamoDB is NoSQL and not suited for relational data. Your organization wants to host a static website that is scalable, cost-effective, and globally available. Options: A. Use EC2 instances with an auto-scaling group. B. Use S3 with CloudFront for global distribution. C. Use RDS for hosting website content. D. Use DynamoDB with an EC2-based web server. Correct answer, B. Use S3 with CloudFront for global distribution. Explanation: hosting the static website in S3 is highly cost-effective, and using CloudFront ensures global distribution with caching. Why not other options? Option A. Using EC2 is overkill for static content and not cost-effective. Option C. RDS is for relational databases, not hosting static websites. Option D. DynamoDB doesn't handle file storage for static websites. Your application processes sensitive customer data and requires encryption keys for encryption/decryption operations. You want to minimize the management overhead for keys. Options: A. Use Amazon EC2 Instance Store for key storage. B. Use AWS Secrets Manager to generate and store encryption keys. C. Use AWS Key Management Service, KMS, for managing encryption keys. D. Use S3 server-side encryption with customer-provided keys. Correct answer: C. Use AWS Key Management Service, KMS, for managing encryption keys. Explanation: AWS KMS provides a secure and scalable way to manage encryption keys with minimal operational overhead. Why not other options? Option A. EC2 Instance Store isn't secure or persistent for key storage. Option B. Secrets Manager is for storing credentials, not managing encryption keys. Option D. S3 server-side encryption with customer-provided keys requires the application to handle keys, increasing complexity. Your media company needs to process videos uploaded by users and generate multiple resolutions, for 80p, 720p, 1080p, for playback. The system must be scalable and cost-effective. Options: A. Use EC2 instances with FFmpeg installed. B. Use AWS Lambda with FFmpeg. C. Use AWS Elastic Transcoder. D. Use AWS Elemental Media Convert. Correct answer: D. Use AWS Elemental Media Convert. Explanation: Media Convert is designed for video transcoding workflows and supports generating multiple resolutions. It's a fully managed service and scales automatically. Why not other options? Option A. EC2 instances require manual scaling and are costlier. Option B. Lambda isn't suitable for long-running video processing tasks due to its timeout limits. Option C. Elastic Transcoder is outdated and lacks advanced features compared to Media Convert. You are building an API for a web application that will handle millions of requests daily. The solution must scale automatically, be highly available, and minimize operational overhead. Options: A. Use an application load balancer, ALB, with auto-scaling EC2 instances. B. Use API Gateway with AWS Lambda. C. Use a network load balancer, NLB, with EC2 instances. D. Use an ALB with ECS Fargate. Correct answer: B. Use API Gateway with AWS Lambda. Explanation: API Gateway with Lambda provides a serverless solution that scales automatically, requires no infrastructure management, and is cost-effective for high-traffic APIs. Why not other options? Option A. While this setup is scalable, it requires managing EC2 instances and incurs additional costs for auto-scaling and ALB. Option C. NLB is better suited for TCP/UDP traffic, not HTTP/HTTPS APIs. Option D. While ECS Fargate simplifies container management, it's still not as operationally lightweight or cost-efficient as Lambda for APIs. You manage an application that stores critical business data in Amazon S3. You must ensure disaster recovery across AWS regions with minimal data loss and low RTO, recovery time objective. Options: A. Enable S3 versioning. B. Enable S3 cross-region replication, CRR. C. Use S3 Glacier for disaster recovery. D. Use AWS Backup to create backups of the S3 bucket. Correct answer: B. Enable S3 cross-region replication, CRR. Explanation: CRR replicates objects to a bucket in another AWS region, ensuring that data is available even if the primary region is unavailable. Why not other options? Option A, versioning provides protection against accidental deletions, but doesn't replicate data to another region. Option C, Glacier is for archiving, not real-time disaster recovery. Option D, AWS Backup doesn't currently support direct backups for S3. Your application requires a high-performance NoSQL database with predictable single-digit millisecond latency for both reads and writes. The database must also handle millions of requests per second. Options: A. Use DynamoDB with provisioned capacity. B. Use DynamoDB with on-demand capacity. C. Use RDS MySQL with read replicas. D. Use Amazon Elasticache for Redis. Correct answer: A. Use DynamoDB with provisioned capacity. Explanation: DynamoDB with provisioned capacity ensures consistent, high performance for predictable workloads, and can handle millions of requests per second. Why not other options? Option B, on-demand capacity is better for unpredictable traffic but isn't as cost-effective for steady, high traffic. Option C, RDS MySQL isn't designed for NoSQL workloads or extremely high throughput. Option D, Elasticache is for caching, not for primary NoSQL data storage. Your company is migrating a legacy monolithic application to AWS. The application has a database tightly coupled with the application layer, and downtime must be minimized during migration. Options: A. Use the AWS Snowball family to transfer data. B. Use AWS Database Migration Service, DMS, for a live migration. C. Use RDS with multi-AZ deployment for the database and manually migrate the app. D. Use Amazon EC2 instances with Elastic Block Store, EBS, for both app and database. Correct answer: B. Use AWS Database Migration Service, DMS, for a live migration. Explanation: DMS allows live database migration with minimal downtime and supports heterogeneous and homogeneous migrations. Why not other options? Option A, Snowball is for offline data transfer, not live migrations. Option C, RDS with multi-AZ is for high availability but doesn't address live migration. Option D, EC2 with EBS is operationally intensive and not suitable for minimizing downtime during migration. You need to process massive amounts of log data daily, transform it, and generate insights using SQL queries. The solution must scale automatically and be cost-effective. Options: A. Use Amazon EMR with Apache Spark. B. Use AWS Glue with Athena. C. Use Amazon Redshift. D. Use Kinesis Data Analytics. Correct answer: B. Use AWS Glue with Athena. Explanation: Glue automates the ETL process, and Athena provides serverless SQL querying over data stored in S3, making this combination cost-effective for analytics workflows. Why not other options? Option A, EMR is scalable but requires infrastructure management and is more expensive for daily batch jobs. Option C, Redshift is designed for data warehousing but may incur unnecessary costs for large-scale batch processing. Option D, Kinesis Data Analytics is for real-time streaming, not batch analytics. You have an EC2 instance hosting an internal application. The application must be accessed securely by users from your corporate office over the internet. Options: A. Use a Bastion host for secure access. B. Configure an elastic load balancer with SSL termination. C. Use AWS Client VPN. D. Use S3 with signed URLs for access. Correct answer: C. Use AWS Client VPN. Explanation: Client VPN allows secure access to internal resources on AWS over the internet using a VPN connection. Why not other options? Option A, a Bastion host is for managing EC2 instances, not for accessing applications securely. Option B, an ELB provides load balancing, but it doesn't establish a secure VPN connection. Option D, signed URLs are for granting temporary access to S3 objects, not applications. Your financial services application needs to process transactions in real time and detect fraud using a machine learning model. Options: A. Use Kinesis data streams with Lambda for processing. B. Use AWS SageMaker for real-time processing. C. Use Kinesis data analytics with DynamoDB. D. Use SQS with Lambda and SageMaker. Correct answer: A. Use Kinesis data streams with Lambda for processing. Explanation: Kinesis data streams can ingest and process real-time transactions, and Lambda can invoke the ML model for fraud detection. Why not other options? Option B. SageMaker is for training and deploying models but doesn't handle real-time data ingestion. Option C. Kinesis data analytics is for SQL-based analytics, not running ML models. Option D. SQS isn't designed for high-throughput real-time data ingestion. A company generates 10 terabytes of log data daily that needs to be retained for compliance. The data must be archived in a cost-effective manner, with retrieval times under 10 minutes for regulatory audits. Options: A. Store the data in Amazon S3 Glacier Deep Archive. B. Store the data in Amazon S3 with intelligent tiering. C. Store the data in Amazon S3 Glacier Flexible Retrieval. D. Store the data in Amazon RDS with multi-AZ. Correct answer: C. Store the data in Amazon S3 Glacier Flexible Retrieval. Explanation: S3 Glacier Flexible Retrieval provides low-cost storage for archival data while allowing retrieval in 1 to 5 minutes using expedited retrievals, meeting the 10-minute SLA. Why not other options? Option A. Glacier Deep Archive is the most cost-effective but has a retrieval time of 12 hours, unsuitable for the scenario. Option B. Intelligent tiering is more expensive than Glacier services and is not optimized for purely archival data. Option D. RDS is a database service and is significantly costlier for storing large volumes of log data. Your web application is read-heavy and serves millions of users globally. The content changes weekly, and the infrastructure must provide low latency to users worldwide. Options: A. Use S3 with CloudFront as the CDN. B. Deploy EC2 instances in multiple regions with an application load balancer. C. Use Amazon RDS with read replicas in multiple regions. D. Use DynamoDB with global tables. Correct answer: A. Use S3 with CloudFront as the CDN. Explanation: S3 with CloudFront enables global content delivery with low latency. Weekly updates to content can be handled efficiently by invalidating CloudFront cache where necessary. Why not other options? Option B. Deploying EC2 instances in multiple regions is operationally complex and more expensive. Option C. RDS read replicas are better suited for database workloads, not static content delivery. Option D. DynamoDB is for NoSQL databases, not static content like web assets. Your organization has multiple AWS accounts for different teams. You need a centralized way to manage security, detect vulnerabilities, and enforce compliance across all accounts. Options: A. Use AWS Control Tower with AWS Config. B. Use Amazon Inspector in each account. C. Use AWS Security Hub with AWS Organizations. D. Use CloudTrail with IAM policies. Correct answer: C. Use AWS Security Hub with AWS Organizations. Explanation: Security Hub integrates with AWS Organizations to provide centralized visibility into security findings, compliance, and best practices across accounts. Why not other options? Option A. Control Tower helps set up multi-account environments, but doesn't provide ongoing security monitoring. Option B. Inspector is for specific vulnerability assessments and would require manual setup in each account. Option D. CloudTrail provides logging but doesn't enforce compliance or security monitoring. You need to process files uploaded to S3 by performing ETL operations and saving the transformed data back to another S3 bucket. The solution must be serverless and scalable. Options: A. Use Lambda with S3 event notifications. B. Use Glue ETL jobs triggered by CloudWatch events. C. Use EMR clusters with Apache Spark. D. Use step functions with Lambda and DynamoDB. Correct answer: B. Use Glue ETL jobs triggered by CloudWatch events. Explanation: AWS Glue is purpose-built for ETL workflows, and triggering it via CloudWatch events allows serverless, scalable processing of S3 uploads. Why not other options? Option A: while Lambda can process files, it's not ideal for complex ETL tasks involving data transformations. Option C: EMR is overkill for a simple ETL workflow and requires infrastructure management. Option D: step functions can orchestrate workflows, but Glue is more efficient for ETL-specific tasks. Your application experiences unpredictable traffic spikes, especially during flash sales. It must handle the spikes automatically without downtime and keep costs low. Options: A. Use an auto-scaling group with EC2 instances. B. Use AWS Elastic Beanstalk with auto-scaling enabled. C. Use AWS Lambda with API Gateway. D. Use EC2 instances with a fixed capacity and elastic load balancer. Correct answer: C. Use AWS Lambda with API Gateway. Explanation: Lambda with API Gateway automatically scales based on the number of requests and is serverless, reducing costs when the application is idle. Why not other options? Option A: EC2 auto-scaling is effective but incurs costs for instance management even during idle times. Option B: Elastic Beanstalk simplifies deployment but still requires EC2 instances, leading to higher costs during idle periods. Option D: Fixed capacity can't handle unpredictable traffic spikes. A company wants to keep frequently accessed data on-premises while moving archived data to AWS. The solution should allow seamless access to archived data without manual transfers. Options: A. Use AWS Storage Gateway with the File Gateway configuration. B. Use S3 with lifecycle policies. C. Use AWS Data Sync to transfer data periodically. D. Use Amazon EFS for storing archived data. Correct answer: A. Use AWS Storage Gateway with the File Gateway configuration. Explanation: File Gateway enables local caching of frequently accessed files while storing less frequently used data in S3, making it ideal for hybrid cloud storage. Why not other options? Option B: Lifecycle policies are for managing S3 data, not on-premises integration. Option C: Data Sync transfers data but doesn't provide seamless access to archived files. Option D: EFS is a fully managed file system but doesn't provide hybrid storage integration. Your company's primary database is hosted on RDS. You need to set up disaster recovery in another AWS region with minimal downtime and data loss. Options: A. Use multi-AZ RDS deployment. B. Use cross-region read replicas and promote them during failover. C. Use AWS Backup for daily snapshots. D. Use DynamoDB global tables. Correct answer: B. Use cross-region read replicas and promote them during failover. Explanation: Cross-region read replicas allow replication of the database in another region. Promoting a replica during a failover minimizes downtime and data loss. Why not other options? Option A: Multi-AZ deployments are within a single region and don't protect against regional outages. Option C: AWS Backup doesn't provide real-time replication, recovery involves downtime. Option D: DynamoDB is not a relational database and isn't suitable for RDS workloads. Your company provides a global API service used by customers in the US and Europe. The API needs to achieve low latency for users in both regions while being cost-effective. The service requires a failover mechanism to handle regional outages. Options: A. Deploy API Gateway and Lambda in one region and use Route 53 latency-based routing. B. Deploy API Gateway and Lambda in both regions, using Route 53 latency-based routing. C. Deploy EC2 instances behind an ALB in one region, with CloudFront caching for global distribution. D. Deploy API Gateway in one region with DynamoDB global tables for regional replication. Correct answer: B. Deploy API Gateway and Lambda in both regions, using Route 53 latency-based routing. Explanation: API Gateway and Lambda in multiple regions provide low latency by serving requests close to the user. Route 53 latency-based routing ensures that users are directed to the nearest region. In case of a regional outage, Route 53 will redirect traffic to the healthy region. Why not other options? Option A. Deploying in one region increases latency for users in the other region and fails to meet the failover requirement. Option C. EC2 with ALB is more expensive and requires infrastructure management compared to serverless API gateway and Lambda. Option D. DynamoDB global tables solve the data replication issue but do not address API latency or failover. Your company wants to implement a data lake for storing structured, semi-structured, and unstructured data. Data needs to be ingested from on-premises systems and queried by analysts using standard SQL. The solution must be cost-effective and scalable. Options: A. Use Amazon S3 with AWS Glue and Athena. B. Use Amazon Redshift with Spectrum and Kinesis Data Firehose. C. Use DynamoDB for storage and Amazon QuickSight for analytics. D. Use S3 with EMR and Hive. Correct answer: A. Use Amazon S3 with AWS Glue and Athena. Explanation: S3 provides cost-effective, scalable storage for a data lake. AWS Glue catalogs the data, and Athena enables serverless SQL queries on S3 data. Why not other options? Option B. Redshift Spectrum is effective for querying S3, but Redshift introduces higher costs for maintaining a cluster. Option C. DynamoDB is a NoSQL database, unsuitable for a data lake. QuickSight is for visualization, not querying. Option D. EMR with Hive adds unnecessary complexity and higher costs compared to serverless Athena. Your multi-tier web application is deployed on EC2 instances in a single region. You need to implement disaster recovery, DR, in a secondary region to minimize downtime during a regional outage. The RTO is 4 hours, and the RPO is 1 hour. Options: A. Use multi-AZ deployments for EC2 and RDSB. Set up a pilot-light architecture in a secondary region with replication. C. Deploy resources in the secondary region and configure them as active-active. D. Use AWS Backup for EC2 and RDS snapshots and restore during failover. Correct answer: B. Set up a pilot-light architecture in a secondary region with replication. Explanation: Pilot-light architecture keeps minimal resources running in the secondary region, e.g. database replication and a small app server footprint. During failover, scale resources to handle full production workloads, meeting the 4-hour RTO and 1-hour RPO. Why not other options? Option A. Multi-AZ is within a single region and doesn't address regional outages. Option C. Active-active increases costs significantly and is unnecessary for the stated RTO and RPO. Option D. Restoring from AWS backup may exceed the 4-hour RTO. You are migrating a high-performance OLTP database from on-premises to AWS. The database requires low-latency access and supports over 100,000 transactions per second. Options: A. Use Amazon Aurora with multi-AZ. B. Use Amazon RDS for MySQL with read replicas. C. Use DynamoDB with on-demand capacity. D. Use Amazon Redshift for high-performance queries. Correct answer: A. Use Amazon Aurora with multi-AZ. Explanation: Aurora is designed for high-performance OLTP workloads, supports low-latency access, and scales to handle hundreds of thousands of transactions per second. Multi-AZ ensures high availability. Why not other options? Option B. RDS MySQL has lower performance limits compared to Aurora. Option C. DynamoDB is for NoSQL workloads and lacks relational database features. Option D. Redshift is designed for OLAP workloads, not OLTP. Your company processes terabytes of data daily using EC2 instances running Spark jobs. The jobs run during business hours and remain idle otherwise. The company wants to reduce costs without affecting performance. Options: A. Migrate to EMR with spot instances. B. Migrate to AWS Glue for serverless data processing. C. Use auto-scaling with EC2 reserved instances. D. Use EC2 with savings plans. Correct answer, A. Migrate to EMR with spot instances. Explanation: EMR with spot instances significantly reduces costs by leveraging spot pricing for Spark jobs. EMR automatically provisions and terminates instances based on job requirements. Why not other options? Option B, AWS Glue is serverless but may not handle Spark workloads efficiently for terabytes of data. Option C, reserved instances are more expensive for workloads that aren't continuously running. Option D, savings plans offer discounts but don't reduce costs as effectively as spot instances for intermittent workloads. A company needs to securely connect its on-premises data center to its VPC in AWS for hybrid cloud operations. The connection must support high bandwidth and low latency. Options: A. Use AWS Direct Connect with a VPN backup. B. Use a VPN connection over the Internet. C. Use a VPC peering connection. D. Use AWS Global Accelerator. Correct answer, A. Use AWS Direct Connect with a VPN backup. Explanation: Direct Connect provides a dedicated, high-bandwidth, low-latency connection. A VPN backup ensures connectivity during Direct Connect outages. Why not other options? Option B, VPN over the Internet doesn't meet the high bandwidth and low latency requirements. Option C, VPC peering is for connecting VPCs, not on-premises data centers. Option D, Global Accelerator improves application performance but doesn't provide hybrid connectivity. You are tasked with designing a highly available e-commerce website. The application should handle sudden traffic spikes during sales events, scale globally, and maintain session consistency. Options: A. Use ALB with EC2 instances in an auto-scaling group across multiple availability zones. B. Use ALB with ECS, Fargate, across multiple availability zones. C. Use CloudFront with Lambda at Edge and S3 for static content, and ALB with ECS for dynamic content. D. Use an Elastic Load Balancer, ELB, and RDS for the backend database. Correct answer, C. Use CloudFront with Lambda at Edge and S3 for static content, and ALB with ECS for dynamic content. Explanation: CloudFront with Lambda at Edge and S3 handles static content delivery at low latency for a global audience. ECS, Fargate, with ALB scales dynamically to handle traffic spikes for dynamic content, reducing management overhead. Why not other options? Option A, works well for dynamic content but doesn't optimize static content delivery globally. Option B, similar to A, but lacks the efficiency of offloading static content to S3 and CloudFront. Option D, ELB is outdated, and this setup doesn't provide global distribution or scaling for sudden spikes. Your financial services company must comply with regulations requiring daily backups of databases for 7 years. The solution must minimize storage costs while ensuring data integrity. Options: A. Use RDS automated backups with a 7-year retention period. B. Use RDS manual snapshots stored in S3 Glacier Deep Archive. C. Use AWS Backup to take RDS snapshots and store them in S3 Standard. D. Use DynamoDB with on-demand backups. Correct answer: B. Use RDS manual snapshots stored in S3 Glacier Deep Archive. Explanation: S3 Glacier Deep Archive is cost-effective for long-term storage of infrequently accessed data. RDS manual snapshots provide point-in-time backups. Why not other options? Option A, RDS automated backups cannot retain data for 7 years. Option C, S3 Standard is significantly more expensive than Glacier Deep Archive for long-term storage. Option D, DynamoDB backups aren't relevant for relational databases like RDS. Your company needs to analyze web server logs in real time to detect security threats. The solution must be scalable, with minimal operational overhead. Options: A. Use Amazon Kinesis data streams with Lambda for processing. B. Use an EC2 instance running Elasticsearch for log analysis. C. Use AWS Glue with Amazon Athena for querying logs. D. Use DynamoDB for storing logs and Amazon QuickSight for visualization. Correct answer: A. Use Amazon Kinesis data streams with Lambda for processing. Explanation: Kinesis data streams ingests real-time data, while Lambda processes and analyzes the logs in real time, providing scalability and low operational overhead. Why not other options? Option B, EC2 with Elasticsearch involves high operational overhead and doesn't scale automatically. Option C, Glue and Athena are for batch analysis, not real-time processing. Option D, DynamoDB is unsuitable for high-volume log storage, and QuickSight is for visualization, not analysis. Your company is migrating a monolithic application hosted on-premises to AWS. The application has tightly coupled components, and the database needs high availability. Options: A. Use EC2 instances in a single AZ and RDS multi-AZ for the database. B. Use EC2 instances in an auto-scaling group across multiple AZs with RDS multi-AZ. C. Refactor the application into microservices using ECS and DynamoDB. D. Use AWS Lambda with DynamoDB for serverless migration. Correct answer: B. Use EC2 instances in an auto-scaling group across multiple AZs with RDS multi-AZ. Explanation: auto-scaling ensures availability of the application servers, while RDS multi-AZ provides high availability for the database without significant refactoring. Why not other options? Option A, single AZ introduces a single point of failure. Option C, refactoring to microservices is ideal, but time-consuming for a monolithic application. Option D, Lambda and DynamoDB aren't suitable for migrating tightly coupled monolithic apps. You are tasked with building a scalable serverless chat application that delivers messages in real time and stores chat history for retrieval. Options: A. Use API Gateway with Lambda for messages and DynamoDB for storage. B. Use S3 for message storage and SNS for message delivery. C. Use Kinesis data streams for message delivery and RDS for chat history. D. Use Elastic Beanstalk with EC2 for hosting and RDS for chat history. Correct answer: A. Use API Gateway with Lambda for messages and DynamoDB for storage. Explanation: API Gateway and Lambda handle real-time message delivery, while DynamoDB stores chat history with low-latency retrieval. Why not other options? Option B, S3 is unsuitable for real-time message storage, and SNS cannot persist messages. Option C, Kinesis is for real-time streaming but doesn't store data persistently. Option D, Elastic Beanstalk adds unnecessary operational overhead for a serverless use case. Your IoT devices generate telemetry data every second. You need a solution to aggregate this data, process it in near real time, and store it for analytics. Options: A. Use AWS IoT Core with DynamoDB and QuickSight. B. Use Kinesis data streams with Lambda and S3. C. Use EC2 instances with a MongoDB database. D. Use SQS with Lambda and RDS. Correct answer: B. Use Kinesis data streams with Lambda and S3. Explanation: Kinesis data streams ingests large volumes of telemetry data in real time. Lambda processes the data, and S3 stores it for analytics. Why not other options? Option A, IoT Core is for device management and communication, not real-time data processing. Option C, EC2 and MongoDB involve high operational complexity and cost. Option D, SQS is not designed for real-time streaming of large volumes of data. Your organization wants to build a data lake to store raw and processed data for machine learning workloads. The solution must support querying without moving data and be cost-effective. Options: A. Use S3 as the data lake, Glue for ETL, and Athena for querying. B. Use EFS as the data lake, Redshift for processing, and Lambda for querying. C. Use RDS for storing data, Glue for ETL, and DynamoDB for querying. D. Use DynamoDB as the data lake, Kinesis for ingestion, and QuickSight for querying. Correct answer: A. Use S3 as the data lake, Glue for ETL, and Athena for querying. Explanation: S3 is the most cost-effective and scalable option for a data lake. Glue automates ETL tasks, and Athena allows you to query data directly from S3 without moving it. Why not other options? Option B, EFS is expensive and not optimized for data lake use cases. Redshift is overkill for this scenario. Option C, RDS is not designed for storing raw, unstructured data. Glue and DynamoDB are not suitable for querying large datasets. Option D, DynamoDB is a NoSQL database, not a data lake. It cannot handle large-scale unstructured data efficiently. Your company runs a global website. You need a disaster recovery solution with an RTO, recovery time objective, of 5 minutes and an RPO, recovery point objective, of near zero. Options: A. Use Route 53 latency-based routing, replicate data using RDS read replicas in a different region. B. Use CloudFront with S3 for static content, and enable cross-region replication for S3. C. Use Route 53 failover routing and replicate data using DynamoDB global tables. D. Use AWS Backup to take snapshots of resources every hour. Correct answer: C. Use Route 53 failover routing and replicate data using DynamoDB global tables. Explanation: Route 53 failover routing ensures traffic is routed to a secondary region during a failure. DynamoDB global tables provide active-active replication with near-zero RPO. Why not other options? Option A, RDS read replicas are read-only and not suitable for active-active architectures. Option B, cross-region replication for S3 only covers static content, not dynamic applications. Option D, AWS backup snapshots every hour exceed the RTO of 5 minutes and don't achieve near-zero RPO. You need to build a secure backend for a mobile application that will serve millions of users. The solution should provide authentication and scale automatically. Options: A. Use API Gateway with Lambda, Cognito for authentication, and DynamoDB for storage. B. Use EC2 with a custom authentication service and RDS for storage. C. Use Elastic Beanstalk with a PostgreSQL database and AWS Secrets Manager for authentication. D. Use S3 for static content and IAM for user authentication. Correct answer: A. Use API Gateway with Lambda, Cognito for authentication, and DynamoDB for storage. Explanation: API Gateway scales automatically, Lambda removes the need to manage servers, Cognito simplifies user authentication, and DynamoDB handles millions of users with low latency. Why not other options? Option B, EC2 adds operational overhead, and a custom authentication service is complex to maintain. Option C, Elastic Beanstalk is less suitable for scaling API-based applications, compared to API Gateway. Option D, S3 is not for dynamic API services, and IAM is unsuitable for end-user authentication. Your company needs to deliver live video streaming for a global audience, with minimal latency. Options: A. Use S3 for video storage, CloudFront for distribution, and Lambda for processing. B. Use MediaLib with Media Package for streaming and CloudFront for delivery. C. Use EC2 instances for video transcoding and RDS for metadata storage. D. Use Kinesis video streams with DynamoDB for metadata and S3 Glacier for archiving. Correct answer: B. Use MediaLib with Media Package for streaming and CloudFront for delivery. Explanation: MediaLib and Media Package handle live video processing and packaging for global delivery. CloudFront ensures low-latency content delivery worldwide. Why not other options? Option A, S3 and Lambda are not designed for live video streaming. Option C, EC2 adds significant operational complexity and doesn't scale automatically. Option D, Kinesis video streams is for IoT video ingestion, not live streaming for audiences. Your organization requires an automated solution to deploy infrastructure across multiple accounts and regions while maintaining compliance. Options: A. Use AWS CloudFormation stack sets. B. Use AWS Code Deploy with manual approval steps. C. Use EC2 instances with scripts to deploy resources. D. Use the AWS Management Console to create resources manually. Correct answer: A. Use AWS CloudFormation stack sets. Explanation: CloudFormation Stack Sets enables you to deploy and manage infrastructure as code across multiple accounts and regions. Why not other options? Option B: Code Deploy is for application deployment, not infrastructure. Option C: EC2 scripts introduce operational overhead and are error-prone. Option D: Manual creation is not scalable or compliant. Your marketing team wants to analyze clickstream data from a global e-commerce website. The solution must be able to handle petabytes of data. Options: A. Use Kinesis data streams for ingestion, Firehose for delivery to S3, and Redshift for analytics. B. Use SQS for ingestion, DynamoDB for storage, and QuickSight for visualization. C. Use RDS for storage and Glue for ETL jobs. D. Use EMR with HDFS for storage and Athena for querying. Correct answer: A. Use Kinesis data streams for ingestion, Firehose for delivery to S3, and Redshift for analytics. Explanation: Kinesis data streams ingests real-time data, Firehose delivers it to S3, and Redshift processes petabytes of data for analytics. Why not other options? Option B: SQS and DynamoDB are not suited for handling petabytes of analytics data. Option C: RDS cannot handle the scale of clickstream data. Option D: EMR with HDFS is more complex and costly compared to the Kinesis Firehose Redshift stack. Your company has a critical transactional database running on RDS MySQL in Region A. You are tasked with designing a cost-effective disaster recovery solution in Region B with an RTO of 1 hour and an RPO of 5 minutes. Options: A. Use RDS read replica in Region B. B. Enable RDS multi-AZ deployment across regions. C. Take manual snapshots and restore them in Region B when needed. D. Use AWS Database Migration Service, DMS, with a continuous replication task to Region B. Correct answer: D. Use AWS Database Migration Service, DMS, with a continuous replication task to Region B. Explanation: DMS provides continuous replication for cross-region disaster recovery. It can meet the RPO of 5 minutes while being more cost-effective than other options. Why not other options? Option A: RDS read replicas are read-only, and promoting them adds downtime, which might exceed the 1-hour RTO. Option B: RDS multi-AZ does not support cross-region deployments. Option C: manual snapshots are slow to restore and exceed both the RTO and RPO requirements. Your organization plans to host a static website for a marketing campaign. The website must handle millions of requests during peak traffic and operate at the lowest cost possible. Options: A. Use EC2 instances with an ALB, Application Load Balancer. B. Use S3 with CloudFront and enable S3 transfer acceleration. C. Use an auto-scaling group of EC2 instances with a network load balancer, NLB. D. Use Elastic Beanstalk with an ALB. Correct answer: B. Use S3 with CloudFront and enable S3 transfer acceleration. Explanation: S3 is cost-effective for static content hosting, and CloudFront optimizes delivery by caching content at edge locations. Transfer acceleration can reduce latency for global users. Why not other options? Option A: EC2 and ALB are costly and unnecessary for static websites. Option C: using EC2 instances and NLB for static websites is not cost-effective or scalable. Option D: Elastic Beanstalk adds unnecessary complexity and cost for static websites. 2 AWS accounts need to share sensitive data stored in an S3 bucket while ensuring the least privilege principle. The data must not leave AWS. Options: A. Use S3 bucket policies to grant access to the other account's IAM users. B. Use S3 cross-account access with an IAM role and assume role API. C. Copy the data to the other account using AWS Data Sync. D. Use S3 pre-signed URLs to share the data. Correct answer: B. Use S3 cross-account access with an IAM role and assume role API. Explanation: IAM roles allow secure, controlled, and auditable cross-account access. Assume role API ensures data access is temporary and based on permissions. Why not other options? Option A, bucket policies can work but are less secure and harder to manage than IAM roles. Option C, data sync unnecessarily copies data, increasing cost and complexity. Option D, pre-signed URLs are temporary and not suitable for ongoing access between accounts. You need to design a real-time analytics pipeline for IoT sensor data. The solution must support ingestion, processing, and near real-time visualization. Options: A. Use Kinesis data streams for ingestion, Kinesis data analytics for processing, and QuickSight for visualization. B. Use S3 for ingestion, Glue for processing, and Athena for querying. C. Use DynamoDB streams for ingestion, Lambda for processing, and RDS for storage. D. Use EC2 instances for ingestion, Spark on EMR for processing, and Tableau for visualization. Correct answer: A. Use Kinesis data streams for ingestion, Kinesis data analytics for processing, and QuickSight for visualization. Explanation: Kinesis data streams is optimized for real-time ingestion, Kinesis data analytics processes streaming data, and QuickSight provides near real-time visualization. Why not other options? Option B, S3 and Glue are not designed for real-time analytics, they are batch-oriented. Option C, DynamoDB streams is not ideal for high-volume IoT data ingestion. Option D, EC2 and EMR add operational complexity and cost. Your application uses multiple microservices running in ECS. Each microservice needs access to unique database credentials securely. Options: A. Store credentials in S3 with encryption and restrict access using IAM. B. Use Secrets Manager to store and rotate credentials. C. Use Systems Manager parameter store without encryption. D. Embed credentials in the ECS task definition environment variables. Correct answer: B. Use Secrets Manager to store and rotate credentials. Explanation: Secrets Manager provides secure storage, automatic rotation, and auditing for secrets, ideal for microservices needing unique credentials. Why not other options? Option A, storing secrets in S3 is not recommended as it lacks rotation and direct integration with services. Option C, parameter store without encryption is insecure for sensitive credentials. Option D, embedding credentials in task definitions is insecure and violates best practices. You are tasked with deploying a multi-tier web application. The application must have high availability across 2 availability zones. Options: A. Deploy the application on EC2 instances in a single availability zone with an ELB. B. Use ECS with Fargate across 2 availability zones and an ALB. C. Use Lambda for the application logic and S3 for the frontend. D. Use Elastic Beanstalk in a single availability zone with an RDS instance. Correct answer: B. Use ECS with Fargate across 2 availability zones and an ALB. Explanation: ECS with Fargate simplifies container management and scales across multiple AZs. An ALB ensures traffic is distributed for high availability. Why not other options? Option A, a single AZ cannot provide high availability. Option C, Lambda and S3 are not suitable for complex multi-tier applications. Option D, Elastic Beanstalk in a single AZ lacks high availability. Your company has implemented a data lake on Amazon S3. Multiple teams need controlled access to different datasets in the data lake. You must enforce security and manage granular access controls while ensuring minimal operational overhead. Options: A. Use IAM policies attached to individual users to grant access to datasets. B. Use S3 bucket policies to control access for each team. C. Use lake formation to set up fine-grained access control on the data lake. D. Use CloudFront with signed URLs to provide access to datasets. Correct answer: C. Use lake formation to set up fine-grained access control on the data lake. Explanation: Lake formation simplifies data lake access management with fine-grained permissions and integration with IAM, ensuring secure and scalable access. Why not other options? Option A, IAM policies for individual users are harder to manage and less scalable for large teams. Option B, S3 bucket policies cannot enforce fine-grained access to specific rows or columns in datasets. Option D, CloudFront with signed URLs is not suitable for complex access control in a data lake. You store large datasets in S3 and use Athena for ad hoc querying. The queries are becoming slow due to increasing data volume. How can you optimize query performance? Options: A. Partition the data by frequently queried fields. B. Use glue to transform and compress data into Parquet format. C. Combine partitioning and data compression. D. Move the data to DynamoDB and use PartyQL for querying. Correct answer: C. Combine partitioning and data compression. Explanation: partitioning reduces the amount of data scanned during queries. Parquet compression optimizes storage and speeds up queries by reducing I/O. Why not other options? Option A, partitioning alone is not enough for very large datasets. Option B, compression alone won't optimize partition-based query scans. Option D, DynamoDB is not suitable for analytical workloads. You are tasked with running a compute-intensive simulation for a scientific research project. The workload requires low-latency networking and needs to scale out to thousands of cores. Options: A. Use a large EC2 instance with the maximum number of vCPUs. B. Use EC2 instances with Elastic Fabric Adapter (EFA) in a cluster placement group. C. Use Lambda functions in parallel to perform the simulations. D. Use Amazon EMR with Spark for distributed processing. Correct answer: B. Use EC2 instances with Elastic Fabric Adapter (EFA) in a cluster placement group. Explanation: EFA provides low latency and high bandwidth networking, crucial for HPC workloads. A cluster placement group ensures high-performance networking between instances. Why not other options? Option A, a single large EC2 instance cannot scale to thousands of cores. Option C, Lambda is not suitable for HPC due to its memory and runtime limitations. Option D, EMR is better suited for big data processing, not low-latency HPC simulations. Your e-commerce website is hosted on S3 with CloudFront as the content delivery network. You must use your company's custom TLS certificate for HTTPS communication. Options: A. Upload the certificate to S3 and use it in the bucket policy. B. Upload the certificate to CloudFront using ACM, AWS Certificate Manager. C. Upload the certificate to IAM and attach it to the CloudFront distribution. D. Use a self-signed certificate for CloudFront. Correct answer: B. Upload the certificate to CloudFront using ACM, AWS Certificate Manager. Explanation: ACM allows you to provision and manage custom TLS certificates easily, and CloudFront integrates directly with ACM. Why not other options? Option A, S3 cannot manage certificates for HTTPS communication. Option C, IAM does not support uploading certificates for CloudFront. Option D, self-signed certificates are insecure and not recommended for production. You are migrating a 2 TB PostgreSQL database from on-premises to AWS with minimal downtime. Which strategy should you use? Options: A. Use AWS Database Migration Service, DMS, in full load mode. B. Use DMS in full load and change data capture, CDC, mode. C. Export the database as SQL files and import it into RDSD. Use Snowball Edge to transfer the database to AWS. Correct answer: B. Use DMS in full load and change data capture, CDC, mode. Explanation: full load and CDC mode allows you to migrate the database and continuously sync changes during the migration, minimizing downtime. Why not other options? Option A, full load mode alone doesn't minimize downtime as it doesn't sync ongoing changes. Option C, exporting and importing SQL files can cause significant downtime for large databases. Option D, Snowball Edge is suitable for offline transfers, but not for active databases. You are exposing an API to external clients using API Gateway. The API must be secured to allow access only to authenticated users. Options: A. Use API gateway with a resource policy. B. Use IAM authentication for API gateway. C. Use API gateway with a Lambda authorizer. D. Use API gateway with Cognito user pools for authentication. Correct answer: D. Use API gateway with Cognito user pools for authentication. Explanation: Cognito user pools provide a simple way to manage user authentication and integrate seamlessly with API gateway. Why not other options? Option A. Resource policies cannot enforce user authentication. Option B. IAM authentication is best suited for internal services, not external clients. Option C. Lambda authorizers are flexible but require custom code, adding unnecessary complexity. You are deploying a stateful web application on ECS. The application requires session data to persist across multiple tasks. Options: A. Use DynamoDB to store session data. B. Use EFS to store session data. C. Use S3 to store session data. D. Use an auto-scaling group for ECS tasks with sticky sessions enabled. Correct answer: A. Use DynamoDB to store session data. Explanation: DynamoDB is highly scalable, low latency, and designed for high availability, making it ideal for session data. Why not other options? Option B. EFS is slower and more expensive for small, frequent reads/writes like session data. Option C. S3 is not designed for real-time session data storage. Option D. Sticky sessions tie users to specific tasks, reducing scalability and fault tolerance. Your company hosts a critical web application in AWS. The application runs in a single region and must be prepared for a disaster recovery scenario with a recovery time objective, RTO, of less than 5 minutes. Options: A. Use CloudFormation to recreate the stack in a different region when a disaster occurs. B. Use a multi-region active-active architecture with Route 53 for failover. C. Use a warm standby architecture with Route 53 health checks. D. Use S3 cross-region replication and spin up resources manually in a different region during a disaster. Correct answer: C. Use a warm standby architecture with Route 53 health checks. Explanation: A warm standby provides pre-provisioned but scaled-down resources in a secondary region. During a disaster, Route 53 health checks detect failure and route traffic to the secondary region. RTO of less than 5 minutes is achievable as the resources are already provisioned. Why not other options? Option A. CloudFormation would take too long to recreate the stack, exceeding the 5-minute RTO. Option B. Active-active is more complex and expensive than necessary. Option D. Manual intervention would delay recovery beyond 5 minutes. You have a monolithic application running on EC2. You want to break it into microservices to improve scalability and maintainability. The application must remain online during the migration. Options: A. Use AWS Lambda to rewrite the entire application as serverless functions. B. Use ECS or EKS to containerize the monolithic app, then gradually decompose it into microservices. C. Migrate the app to Elastic Beanstalk, then refactor it into smaller services. D. Rewrite the entire application in smaller pieces using DynamoDB for storage. Correct answer: B. Use ECS or EKS to containerize the monolithic app, then gradually decompose it into microservices. Explanation: ECS/EKS allows you to lift and shift the monolithic app, enabling gradual decomposition into microservices without disrupting the app's availability. This approach is less risky and ensures the app stays online during migration. Why not other options? Option A. Rewriting the app into Lambda functions is complex, risky, and may cause downtime. Option C. Elastic Beanstalk is better suited for deploying applications but not for gradual refactoring into microservices. Option D. A complete rewrite disrupts availability and is time-consuming. Your application generates millions of log files daily. You need a scalable solution to analyze these logs in near real time. Options: A. Use Kinesis data streams with AWS Lambda to process the logs. B. Use S3 to store logs and Athena to query them periodically. C. Use DynamoDB streams to capture and analyze the logs. D. Use Elastic Beanstalk to deploy a custom log processing application. Correct answer: A. Use Kinesis data streams with AWS Lambda to process the logs. Explanation: Kinesis data streams allows you to ingest and process large amounts of streaming data. Lambda functions process logs in real time, making it an ideal solution for near real-time analytics. Why not other options? Option B. S3 and Athena are more suited for periodic batch processing, not real-time analytics. Option C. DynamoDB streams is designed for capturing database changes, not log processing. Option D. Elastic Beanstalk does not natively support real-time log streaming. Your e-commerce website experiences unpredictable traffic spikes during sales events. The backend runs on EC2 instances in an auto-scaling group, ASG. You want to ensure the application scales quickly during traffic bursts. Options: A. Increase the cooldown period in the ASG configuration. B. Use EC2 spot instances for cost efficiency. C. Pre-warm the ASG by setting a minimum number of instances based on expected peak traffic. D. Enable predictive scaling for the ASG. Correct answer: D. Enable predictive scaling for the ASG. Explanation: Predictive scaling uses historical data and machine learning to predict traffic patterns and proactively scale instances, ensuring the application can handle traffic spikes. Why not other options? Option A. Increasing the cooldown period delays scaling, making it unsuitable for traffic bursts. Option B. Spot instances can be terminated during traffic spikes if capacity is unavailable. Option C. Pre-warming is useful, but not dynamic or cost-effective for unpredictable spikes. Question 1. Your company runs a hybrid cloud environment. On-premises applications need secure and low-latency access to AWS services. Options: A. Use Direct Connect with a private VIF. B. Use a VPN connection to the VPC. C. Use AWS Global Accelerator. D. Use CloudFront to connect on-premises applications to AWS. Correct answer: A. Use Direct Connect with a private VIF. Explanation: Direct Connect provides a dedicated, low-latency, and secure connection between your on-premises data center and AWS. A private virtual interface, VIF, ensures secure communication to your VPC. Why not other options? Option B. VPN is slower and less reliable than Direct Connect for high bandwidth needs. Option C. Global Accelerator improves performance for internet-facing applications, not hybrid connectivity. Option D. CloudFront is for content delivery, not hybrid cloud connections. Question 2. You are storing sensitive customer data in Amazon S3 and must ensure that it is encrypted both in transit and at rest. Options: A. Use S3 default encryption and access the bucket over HTTPS. B. Use client-side encryption and access the bucket over HTTP. C. Use S3 server-side encryption with customer-provided keys, SSEC, and access over HTTP. D. Use S3 bucket policies to enforce encryption. Correct answer: A. Use S3 default encryption and access the bucket over HTTPS. Explanation: S3 default encryption ensures data is encrypted at rest, and HTTPS ensures data is encrypted in transit. Why not other options? Option B. Using HTTP compromises data in transit, even with client-side encryption. Option C. HTTP is insecure for transmitting data, even with SSEC. Option D. Bucket policies enforce encryption at rest but do not ensure encryption in transit. Question 3. Your application allows users to upload large files, up to 1 terabyte, to S3. You want to optimize the upload process for reliability and performance. Options: A. Use S3 transfer acceleration. B. Use multi-part upload. C. Use a pre-signed URL for direct upload. D. Combine transfer acceleration and multi-part upload. Correct answer, D. Combine transfer acceleration and multi-part upload. Explanation: multi-part upload splits large files into parts for parallel upload, while transfer acceleration improves upload speed over long distances. Why not other options? Option A. Transfer acceleration alone does not optimize large file handling. Option B. Multi-part upload improves reliability, but does not address latency. Option C. Pre-signed URLs simplify access, but do not optimize upload performance. Question 4. Your company uses a centralized S3 bucket in account A to store compliance data. Teams in multiple AWS accounts need to upload data to this bucket without exposing account A's credentials. Options: A. Share the bucket policy with the IAM users in other accounts. B. Use an S3 bucket policy to allow cross-account access and have users assume a role in account A. C. Configure bucket access using access control lists, ACLs. D. Use S3 transfer acceleration for secure access. Correct answer, B. Use an S3 bucket policy to allow cross-account access and have users assume a role in account A. Explanation: using a bucket policy with a cross-account role allows secure and auditable access to the bucket without exposing account A's credentials. Users in other accounts can assume the IAM role in account A to perform specific actions, adhering to the principle of least privilege. Why not other options? Option A. Sharing bucket policy alone does not authenticate users across accounts. Option C. ACLs are less flexible and harder to manage than bucket policies and roles. Option D. Transfer acceleration is for faster uploads, not access control. Question 5. You are building a data lake to store and analyze petabytes of structured and unstructured data. Data ingestion must support real-time and batch processes. Options: A. Use S3 as the storage layer and Kinesis data streams for ingestion. B. Use RDS as the storage layer and Athena for querying. C. Use DynamoDB as the storage layer and Glue for ETL. D. Use EBS volumes attached to EC2 for storage and QuickSight for visualization. Correct answer: A. Use S3 as the storage layer and Kinesis data streams for ingestion. Explanation: S3 provides highly scalable and cost-effective storage for a data lake. Kinesis data streams can handle real-time data ingestion, while batch ingestion can be supported by services like Glue or Data Pipeline. Why not other options? Option B. RDS is not designed for scalable storage of unstructured data. Option C. DynamoDB is a NoSQL database, unsuitable for large-scale, unstructured data. Option D. EBS volumes are expensive and not scalable for a data lake. Question 6. Your company wants to deploy containerized applications. They have Kubernetes expertise and prefer open-source tooling, but also want managed services to reduce operational overhead. Options: A. Use ECS with EC2 launch type for better control over instances. B. Use ECS with Fargate to eliminate instance management. C. Use EKS to leverage Kubernetes expertise with AWS management. D. Use Elastic Beanstalk with Docker. Correct answer: C. Use EKS to leverage Kubernetes expertise with AWS management. Explanation: EKS is ideal for teams experienced with Kubernetes as it provides a managed service while maintaining compatibility with open-source tools. Why not other options? Option A. ECS with EC2 launch type adds operational overhead of managing instances. Option B. ECS with Fargate does not leverage Kubernetes expertise. Option D. Elastic Beanstalk with Docker is not as flexible or robust as EKS for container orchestration. Question 7. You are designing a highly available relational database for a critical production workload. The database must automatically failover in case of an issue and must support read scaling. Options: A. Use RDS with multi-AZ and read replicas. B. Use Aurora with read replicas. C. Use DynamoDB global tables. D. Use an EC2 instance with a self-managed MySQL database in a cluster. Correct answer: B. Use Aurora with read replicas. Explanation: Aurora provides automated failover, high performance, and seamless integration with up to 15 RAID replicas for read scaling. Multi-AZ support is built into Aurora for high availability. Why not other options? Option A, RDS Multi-AZ provides failover but not the same level of performance or scalability as Aurora. Option C, DynamoDB is a NoSQL database, not suitable for relational workloads. Option D, managing a MySQL cluster on EC2 increases operational complexity. Question 8. You are deploying a global e-commerce website and need to customize content delivery for different regions. Options: A. Use CloudFront with Lambda at Edge for request-based modifications. B. Use S3 with transfer acceleration. C. Use Global Accelerator to route requests to the nearest region. D. Use Route 53 for latency-based routing. Correct answer: A. Use CloudFront with Lambda at Edge for request-based modifications. Explanation: Lambda at Edge allows you to customize behavior at CloudFront Edge locations, such as modifying headers or serving region-specific content. Why not other options? Option B, S3 transfer acceleration speeds up uploads but does not support request-based customization. Option C, Global Accelerator routes traffic but does not offer content customization. Option D, Route 53 latency-based routing determines the best endpoint but lacks content modification capability. Question 9. Your application has predictable workloads that run daily from 9 a.m. to 5 p.m. You want to reduce costs while ensuring capacity is available during these hours. Options: A. Use on-demand instances. B. Use reserved instances with a 1-year term. C. Use spot instances with a maximum price configured. D. Use savings plans. Correct answer: B. Use reserved instances with a 1-year term. Explanation: Reserved instances provide cost savings for predictable, steady workloads when compared to on-demand pricing. Why not other options? Option A, on-demand instances are the most expensive option. Option C, spot instances are not reliable for time-sensitive workloads due to potential termination. Option D, savings plans are flexible but may not offer as much savings as reserved instances for specific EC2 usage patterns. Question 10. You want to build a serverless event-driven workflow where multiple AWS services, including Lambda, SNS, and SQS, interact. The workflow should be stateful and able to retry failed tasks. Options: A. Use step functions to orchestrate the workflow. B. Use Event Bridge to trigger Lambda functions directly. C. Use SNS to publish events to multiple consumers. D. Use SQS for decoupling services. Correct answer: A. Use step functions to orchestrate the workflow. Explanation: Step functions allow you to define stateful workflows with retries, error handling, and sequential/parallel execution of tasks. Why not other options? Option B, Event Bridge triggers events, but does not support stateful workflows. Option C, SNS delivers messages to multiple subscribers, but lacks workflow orchestration. Option D, SQS queues decouple services, but do not provide orchestration or error handling. Question 1. A financial application requires disaster recovery with a recovery time objective, RTO, of 15 minutes and a recovery point objective, RPO, of 5 minutes. Cost is a major concern. Options: A. Use S3 and enable cross-region replication, CRR. B. Use AWS Backup with daily snapshots of the data. C. Use an active-passive multi-region architecture with RDS read replicas. D. Use an active-active multi-region architecture with Aurora Global Database. Correct answer: D. Use an active-active multi-region architecture with Aurora Global Database. Explanation: Aurora Global Database provides near real-time replication across regions, latency less than 1 second, and immediate failover to the secondary region, meeting the strict RTO and RPO requirements. Why not other options? Option A, S3 with CRR is for object storage, not databases, and does not meet the RTO requirements. Option B, AWS Backup with daily snapshots fails to meet the 5-minute RPO as snapshots occur periodically. Option C, an active-passive setup with RDS read replicas has a longer failover time and slower replication compared to Aurora. Question 2. A media streaming company wants to serve static video content globally with low latency. They want to optimize costs while ensuring scalability. Options: A. Use S3 with transfer acceleration. B. Use EC2 instances with elastic load balancing, ELB. C. Use S3 with CloudFront. D. Use EBS volumes attached to auto-scaling EC2 instances. Correct answer: C. Use S3 with CloudFront. Explanation: S3 provides highly durable and cost-effective storage, while CloudFront caches content globally for low-latency delivery, reducing data transfer costs. Why not other options? Option A, transfer acceleration is for faster uploads, not global content delivery. Option B, hosting static files on EC2 with ELB is more expensive and less scalable. Option D, using EBS with EC2 is unnecessarily complex and costly for static content. Question 3. A legacy on-premises application is being migrated to AWS. The application stores session data in memory and uses a MySQL database. It requires high availability and automatic scaling. Options: A. Use EC2 with MySQL and an ELB. B. Use Elastic Beanstalk with a managed RDS MySQL instance. C. Use ECS with DynamoDB and autoscaling. D. Use Lambda with RDS proxy. Correct answer: B. Use Elastic Beanstalk with a managed RDS MySQL instance. Explanation: Elastic Beanstalk provides a fully managed service for deploying applications with built-in scaling. RDS MySQL ensures high availability and managed backups. Why not other options? Option A, EC2 requires more manual management for scaling and high availability. Option C, DynamoDB is not suitable for relational data, and ECS increases complexity. Option D, Lambda is not suitable for session-heavy applications without significant re-architecture. Question 4. You need to build a real-time analytics pipeline to process streaming data from IoT devices. Data must be transformed and stored for querying. Options: A. Use Kinesis data streams, Lambda, and DynamoDB. B. Use S3, Glue, and Athena. C. Use Kinesis Data Firehose, Lambda, and S3. D. Use Redshift with Data Pipeline. Correct answer: C. Use Kinesis Data Firehose, Lambda, and S3. Explanation: Kinesis Data Firehose ingests streaming data, Lambda transforms it in real time, and S3 stores the data for querying or further processing. Why not other options? Option A, DynamoDB is not suitable for analytics queries and storage of large datasets. Option B, S3, Glue, and Athena are better suited for batch processing, not real-time analytics. Option D, Redshift is optimized for large-scale analytical queries, but it is not designed for real-time ingestion. Question 5. A healthcare company stores sensitive patient data on S3. They require encryption at rest and must rotate encryption keys regularly. Options: A. Use S3 default encryption with SSE/S3. B. Use S3 default encryption with SSE/KMS and enable automatic key rotation. C. Encrypt data client-side before uploading to S3. D. Use a custom encryption library to encrypt data before uploading. Correct answer: B. Use S3 default encryption with SSE/KMS and enable automatic key rotation. Explanation: SSE/KMS allows integration with AWS KMS for key management and automatic rotation, meeting regulatory compliance for key rotation. Why not other options? Option A, SSE/S3 provides encryption but does not allow key rotation or custom key management. Option C, client-side encryption is harder to manage and audit. Option D, custom encryption libraries add complexity and are less secure than managed solutions. Question 6. Your organization needs a web application deployed in multiple AWS regions to serve users with minimal latency. The application uses a single RDS database. Options: A. Use multi-AZ RDS with cross-region read replicas. B. Use Aurora Global Database. C. Use DynamoDB Global Tables. D. Use RDS with multi-region failover enabled. Correct answer: B. Use Aurora Global Database. Explanation: Aurora Global Database replicates data across regions with sub-second latency and supports instant failover for high availability. Why not other options? Option A. Cross-region read replicas introduce higher latency for writes and slower failover. Option C. DynamoDB is not suitable for relational data. Option D. RDS does not natively support multi-region failover. Question 7. A company wants to automate backups of its critical data stored on S3 and retain those backups for 7 years to meet compliance requirements. Options: A. Enable S3 versioning and lifecycle policies. B. Use AWS Backup to schedule and manage S3 backups. C. Use CloudTrail to log S3 access and maintain an audit trail. D. Use Glacier for cold storage of backups. Correct answer: B. Use AWS Backup to schedule and manage S3 backups. Explanation: AWS Backup allows centralized management of backup policies and retention for compliance purposes, supporting S3 backups. Why not other options? Option A. Versioning with lifecycle policies helps manage versions, but does not meet compliance tracking or centralized management. Option C. CloudTrail provides audit logs, not backup capabilities. Option D. Glacier is for archival storage, not backup management. Question 8. A company has an on-premises data center and wants to securely extend its network to AWS using a cost-effective solution. They also need low latency for data transfer between the two environments. Options: A. Use Direct Connect with a dedicated connection. B. Use a site-to-site VPN connection. C. Use AWS Global Accelerator with VPN. D. Use VPC peering. Correct answer: B. Use a site-to-site VPN connection. Explanation: a site-to-site VPN connection is cost-effective, secure, and can extend the on-premises network to AWS with reasonable latency. Why not other options? Option A. Direct Connect provides lower latency and higher bandwidth but is more expensive and not required for this use case. Option C. AWS Global Accelerator improves application performance but does not extend networks. Option D. VPC peering is for connecting two VPCs, not extending on-premises networks. Question 9. Your company needs to store critical data across multiple AWS regions to comply with data sovereignty laws. The solution should provide low-cost storage with easy replication. Options: A. Use S3 with cross-region replication, CRR. B. Use S3 intelligent tiering with lifecycle policies. C. Use RDS read replicas. D. Use DynamoDB global tables. A. Use S3 with cross-region replication, CRR. Explanation: S3 CRR replicates data to another region automatically and securely, ensuring compliance with data sovereignty laws. Why not other options? Option B. Intelligent tiering optimizes cost but does not handle cross-region replication. Option C. RDS read replicas are for database workloads, not general data storage. Option D. DynamoDB global tables are for NoSQL use cases, not object storage. Question 10. A company has Lambda functions processing requests intermittently throughout the day. The functions have memory usage of 1 GB and run for about 2 seconds per invocation, with 10 million invocations per month. They want to optimize costs. Options: A. Reduce the memory allocation of Lambda functions. B. Use provisioned concurrency for Lambda. C. Migrate the workload to EC2 with autoscaling. D. Use step functions to break down the process. Correct answer: A. Reduce the memory allocation of Lambda functions. Explanation: Lambda pricing is based on memory allocation and execution time. Reducing memory allocation can lower costs if performance is not impacted. Why not other options? Option B, provisioned concurrency increases costs and is for high latency reduction, not cost optimization. Option C, EC2 with autoscaling may be costlier due to persistent instances and management overhead. Option D, step functions add orchestration costs and are unnecessary for this scenario.
You are deploying a multi-tier web application with a web tier, an application tier, and a database tier. You need scalability, high availability, and automatic failover for the database. Options: A. Use EC2 instances for all tiers and a multi-AZ RDS instance for the database. B. Use Elastic Beanstalk with DynamoDB. C. Use ECS with Aurora Global Database. D. Use Lambda with S3 for the web tier and RDS Read Replica for the database. Correct answer: C. Use ECS with Aurora Global Database. Explanation: ECS provides scalability for containerized applications, and Aurora Global Database ensures high availability with global replication and failover. Why not other options? Option A, EC2 requires more management effort and lacks global scalability. Option B, DynamoDB is unsuitable for relational data in the database tier. Option D, RDS read replicas do not support automatic failover. Question 2. A data analytics company needs a centralized data lake for storing structured and unstructured data. The data lake must support multiple analytical tools. Options: A. Use DynamoDB with global tables. B. Use Redshift with Redshift Spectrum. C. Use S3 with Glue and Athena. D. Use Elasticsearch with EBS volumes. Correct answer: C. Use S3 with Glue and Athena. Explanation: S3 provides scalable and durable storage for a data lake, while Glue and Athena allow querying and ETL processing of the stored data. Why not other options? Option A, DynamoDB is unsuitable for unstructured data storage. Option B, Redshift Spectrum is ideal for queries on S3 data but does not serve as the primary data lake solution. Option D, Elasticsearch is for search and indexing, not data lakes. Question 3. A large organization operates multiple AWS accounts and wants a centralized monitoring solution. Options: A. Use CloudWatch with cross-account observability. B. Use CloudTrail with organization-level logging. C. Use AWS Config to track all changes in real time. D. Use Amazon QuickSight for centralized dashboards. Correct answer: A. Use CloudWatch with cross-account observability. Explanation: CloudWatch supports cross-account observability through CloudWatch synthetics and contributor insights, providing centralized monitoring for multiple accounts. Why not other options? Option B, CloudTrail provides logging but lacks real-time monitoring. Option C, AWS Config tracks changes but does not offer centralized dashboards. Option D, QuickSight is for business intelligence, not infrastructure monitoring. Question 4. Your company wants to migrate an on-premises data warehouse to AWS. The solution must support complex analytical queries on petabyte-scale datasets. Options: A. Use DynamoDB for analytics. B. Use Aurora PostgreSQL with read replicas. C. Use Redshift. D. Use RDS MySQL with multi-AZ. Correct answer: C. Use Redshift. Explanation: Redshift is purpose-built for large-scale analytical queries and petabyte-scale data warehouses. Why not other options? Option A, DynamoDB is not suitable for complex analytics. Option B, Aurora PostgreSQL cannot handle petabyte-scale datasets efficiently. Option D, RDS MySQL is for OLTP, not OLAP workloads. Question 5. A company hosts a web application on EC2 instances in one region. To ensure minimal downtime during a disaster, they need a cost-effective disaster recovery solution that can scale during failover. Options: A. Use a multi-AZ deployment for EC2 instances. B. Use a backup region with a pre-provisioned fleet of EC2 instances. C. Use S3 for static content and a backup region with an auto-scaling group for EC2. D. Use Global Accelerator to route traffic between two regions. Correct answer: C. Use S3 for static content and a backup region with an auto-scaling group for EC2. Explanation: storing static content in S3 reduces costs, and having an auto-scaling group in the backup region ensures scalability during a failover event. This approach is both cost-effective and resilient. Why not other options? Option A, multi-AZ protects within a single region but does not handle regional disasters. Option B, pre-provisioned EC2 instances in a backup region increase costs unnecessarily. Option D, Global Accelerator improves performance globally but does not help with disaster recovery. Question 6. A company needs to process millions of log events in real time and store them in a data lake for later analysis. Options: A. Use S3 with lifecycle policies to store logs directly. B. Use Kinesis data streams to process and deliver logs to S3. C. Use CloudWatch logs insights for real-time processing. D. Use RDS with a read replica for log storage and analysis. Correct answer: B. Use Kinesis data streams to process and deliver logs to S3. Explanation: Kinesis data streams is designed for high-throughput, real-time log ingestion. It can process log data in real time and deliver it to S3 or other services for storage. Why not other options? Option A, S3 cannot handle real-time log ingestion directly. Option C, CloudWatch logs insights is for querying and analyzing logs, not for real-time ingestion. Option D, RDS is unsuitable for high-throughput, real-time log ingestion. Question 7. A company generates large amounts of data that are rarely accessed but must be retained for 10 years for compliance purposes. Options: A. Use EBS volumes with snapshots for long-term storage. B. Use S3 standard with versioning enabled. C. Use S3 Glacier Deep Archive with lifecycle policies. D. Use DynamoDB for storing the data. Correct answer: C. Use S3 Glacier Deep Archive with lifecycle policies. Explanation: S3 Glacier Deep Archive is the most cost-effective solution for long-term, infrequently accessed data storage. Lifecycle policies can automate data transitions to Glacier Deep Archive. Why not other options? Option A, EBS is too costly for long-term storage. Option B, S3 standard is more expensive and unnecessary for rarely accessed data. Option D, DynamoDB is not designed for long-term archival storage. Question 8. You need to securely allow a third-party application to access specific objects in your S3 bucket. The solution must not expose access keys. Options: A. Use a bucket policy with hard-coded access keys. B. Use a pre-signed URL for temporary access. C. Use an IAM role with assume role for the third-party application. D. Use CloudFront to distribute the content. Correct answer: B. Use a pre-signed URL for temporary access. Explanation: pre-signed URLs provide temporary and secure access to specific S3 objects without exposing access keys. Why not other options? Option A, hard-coding access keys is insecure and violates best practices. Option C, IAM roles with assume role are more suitable for applications running within AWS, not third-party access. Option D, CloudFront is for content delivery and does not solve the access control requirement. Question 9. An e-commerce website experiences traffic spikes during seasonal sales. The architecture should handle sudden increases in traffic and ensure high availability. Options: A. Use an auto-scaling group with an application load balancer, ALB. B. Use EC2 instances with elastic IP addresses. C. Use Lambda functions with an API gateway. D. Use CloudFront with an S3 backend. Correct answer, A. Use an auto-scaling group with an application load balancer, ALB. Explanation: an auto-scaling group with ALB ensures that the application can scale out during traffic spikes and remain highly available. Why not other options? Option B. Elastic IP addresses do not provide scalability or high availability. Option C. Lambda with API gateway is suitable for serverless applications but may not fit a traditional e-commerce website. Option D. CloudFront with S3 is ideal for static websites, not dynamic e-commerce platforms. Question 10. A company is migrating its on-premises Oracle database to AWS. The database must support complex queries, ACID transactions, and minimal downtime during migration. Options: A. Use DynamoDB with DMS for migration. B. Use RDS Oracle with multi-AZ and DMS. C. Use Aurora PostgreSQL and export data using scripts. D. Use Redshift for data storage and queries. Correct answer, B. Use RDS Oracle with multi-AZ and DMS. Explanation: RDS Oracle provides a managed Oracle database with multi-AZ for high availability. DMS ensures minimal downtime during migration. Why not other options? Option A. DynamoDB is a NoSQL database and does not support complex queries or ACID transactions. Option C. Aurora PostgreSQL requires significant re-engineering of the database schema. Option D. Redshift is for analytical workloads, not transactional databases.
Question 1. A media company needs to process live video streams and transcode them into multiple formats for different devices. Options: A. Use Elastic Transcoder for video processing. B. Use Media Convert with Lambda triggers. C. Use Kinesis video streams with MediaLive. D. Use S3 and Athena for processing video streams. Correct answer: C. Use Kinesis video streams with MediaLive. Explanation: Kinesis video streams captures live video, and MediaLive transcodes it into multiple formats for real-time distribution. Why not other options? Option A. Elastic Transcoder is not designed for real-time video processing. Option B. Media Convert is for file-based transcoding, not live streams. Option D. S3 and Athena are not suitable for real-time video processing. Question 2. A financial institution uses an on-premises data center and AWS for hybrid cloud operations. They need a solution to securely extend their internal network to AWS for accessing sensitive data stored in RDS, while minimizing latency and ensuring compliance. Options: A. Use Direct Connect with an IAM policy restricting access. B. Use a VPN connection with network ACLs to restrict traffic. C. Use Direct Connect with AWS Private Link for RDS-D. Use a VPN connection and public IPs for accessing RDS. Correct answer: C. Use Direct Connect with AWS Private Link for RDS. Explanation: Direct Connect provides a low latency, secure connection to AWS. AWS Private Link ensures the RDS database is accessed securely without exposing it to the public internet, adhering to compliance requirements. Why not other options? Option A. Direct Connect alone doesn't ensure secure RDS access. Private Link is needed for private communication. Option B. VPNs introduce higher latency and are less reliable for hybrid workloads requiring low latency communication. Option D. Using public IPs for accessing RDS violates security best practices. Question 3. An analytics company processes large amounts of IoT sensor data daily. They need a cost-efficient and scalable solution for running complex analytical queries while storing raw and processed data for long-term use. Options: A. Store data in S3 and query using Athena. B. Use DynamoDB for storage and EMR for queries. C. Use Redshift Spectrum to query data in S3. D. Store data in RDS and query using SQL. Correct answer: C. Use Redshift Spectrum to query data in S3. Explanation: Redshift Spectrum allows querying structured and semi-structured data directly in S3 without moving it into Redshift, making it cost-efficient for large datasets. Why not other options? Option A: Athena is great for ad hoc queries, but less optimized for complex analytics on massive datasets. Option B: DynamoDB is not suited for large-scale analytical workloads. Option D: RDS cannot handle high-performance analytics on large datasets due to scalability limitations. Question 4. A global e-commerce platform needs to design a highly available, low-latency application for users across multiple regions. The architecture should synchronize user data in real time across all regions. Options: A. Use RDS with multi-AZ and S3 for storage. B. Use DynamoDB Global Tables with CloudFront. C. Use Aurora Global Database with Route 53 latency-based routing. D. Use ElastiCache with manual replication across regions. Correct answer: C. Use Aurora Global Database with Route 53 latency-based routing. Explanation: Aurora Global Database replicates data across multiple regions with sub-second latency, and Route 53 latency-based routing ensures users are directed to the nearest region. Why not other options? Option A: RDS multi-AZ is restricted to a single region. Option B: DynamoDB Global Tables are great for NoSQL, but not for relational data. Option D: ElastiCache does not provide seamless replication across regions for primary data storage. Question 5. A company wants to back up its critical application data stored in EBS volumes. The solution should be automated, cost-effective, and ensure quick recovery in case of data loss. Options: A. Use AWS Backup to schedule and manage EBS snapshots. B. Use S3 with lifecycle policies to archive snapshots. C. Use CloudFormation to automate snapshot creation. D. Use a third-party backup tool to back up EBS volumes. Correct answer: A. Use AWS Backup to schedule and manage EBS snapshots. Explanation: AWS Backup automates EBS snapshot creation and management while integrating with other AWS services, making it the most cost-effective and reliable solution. Why not other options? Option B: S3 cannot directly archive EBS snapshots, snapshots remain in EBS. Option C: CloudFormation is not designed for snapshot management. Option D: third-party tools add unnecessary complexity and costs. Question 6. A company uses a serverless architecture for their e-commerce platform. They need to process orders in real time and ensure messages are not lost even during failures. Options: A. Use SNS with multiple subscribers. B. Use SQS with Lambda for processing. C. Use Kinesis data streams with Lambda. D. Use EventBridge with step functions. Correct answer: B. Use SQS with Lambda for processing. Explanation: SQS ensures messages are not lost by storing them until processed, and Lambda enables real-time processing in a serverless architecture. Why not other options? Option A: SNS does not guarantee message persistence if a subscriber fails. Option C: Kinesis is better suited for streaming data but adds unnecessary complexity for event-driven processing. Option D: EventBridge is for event-driven integrations but lacks SQS-like message durability. Question 7. A SaaS provider needs to secure a multi-tenant application hosted on AWS. Each tenant's data must be isolated, and the application should scale easily. Options: A. Use separate S3 buckets for each tenant. B. Use DynamoDB with fine-grained access control. C. Use a separate VPC for each tenant. D. Use an RDS instance with IAM authentication. Correct answer: B. Use DynamoDB with fine-grained access control. Explanation: DynamoDB with fine-grained access control allows you to isolate tenant data securely within the same database table, and its scalability is ideal for multi-tenant SaaS applications. Why not other options? Option A: managing separate S3 buckets for each tenant increases operational complexity. Option C: separate VPCs for each tenant are unnecessary and expensive. Option D. RDS lacks scalability for a high number of tenants. Question 8. A company needs to build a data lake to store raw IoT data and enable real-time insights for operational efficiency. Options: A. Use S3 for storage and EMR for real-time processing. B. Use S3, Glue, and Athena for analytics. C. Use S3 with Kinesis Data Firehose and QuickSight. D. Use RDS for storage and Tableau for analytics. Correct answer: C. Use S3 with Kinesis Data Firehose and QuickSight. Explanation: Kinesis Data Firehose enables real-time ingestion into S3, and QuickSight provides real-time visualization, making it the best combination for real-time insights in a data lake architecture. Why not other options? Option A. EMR is overkill for real-time processing. Option B. Glue and Athena are great for batch processing, not real-time insights. Option D. RDS and Tableau are not designed for real-time IoT data ingestion or visualization. Question 9. A company needs a disaster recovery solution for a critical application hosted on EC2 instances in one region. They want minimal recovery time objective, RTO, and recovery point objective, RPO, while keeping costs low. Options: A. Use AWS Backup to create EBS snapshots and replicate them to another region. B. Use cross-region replication with S3 to backup AMIs. C. Use pilot-light architecture with EC2 instances pre-provisioned in another region. D. Use multi-region Aurora database with Route 53 latency-based routing. Correct answer: C. Use pilot-light architecture with EC2 instances pre-provisioned in another region. Explanation: the pilot-light architecture keeps minimal infrastructure running in another region, e.g. a small database and pre-configured AMIs, ensuring quick recovery and low costs. Why not other options? Option A. Backups alone do not meet low RTO as they require manual recovery and provisioning. Option B. S3 AMI backups cannot ensure quick failover due to recovery delays. Option D. Multi-region Aurora covers only databases, not EC2 workloads. Question 10. A media company processes thousands of video files daily. They need to convert videos to multiple resolutions, automate the process, and minimize infrastructure management. Options: A. Use EC2 auto-scaling for running Fmpeg scripts. B. Use Lambda with S3 and AWS step functions. C. Use Elastic Beanstalk with scheduled tasks. D. Use ECS with Fargate for running batch jobs. Correct answer: B. Use Lambda with S3 and AWS step functions. Explanation: Lambda triggers when videos are uploaded to S3, and step functions orchestrate the workflow, making it a serverless and fully managed solution. Why not other options? Option A. EC2 requires significant infrastructure management. Option C. Elastic Beanstalk does not support fine-grained orchestration. Option D. ECS with Fargate is overkill for simple video processing workflows.